Hello everybody, welcome to the Python course. And the reason to learn Python nowadays is that Python is a really easy language to learn, and it is pretty much versatile. So that when you are familiar with Python, you're able to learn other languages. And nowadays, many applications are built upon Python, from server management to scientific calculations. So before we do the real programming, we have to install Python first. I would like to suggest Anaconda distribution, which contains the Python interpreter as well as other components that can help you do the programming a bit easier. So we go to this web page, anaconda.com/download, and then we choose the appropriate operating system. For my case, I'm using Linux, so I can simply choose Linux. And I would like to download the 3.7 version. And we don't do Python 2 now because Python 2 is an obsolete language and it will be phased out in a few years' time from now. I would save the file. Okay, the download is complete. So I would go to the terminal. Terminal here. Go to downloads. Bash Anaconda. Yes, that one. Enter. So many lines. I would continuously press enter. I choose yes to end the declaration statements. Then I can follow the default path by pressing enter. Now Anaconda is being installed. Okay, now the installation is about to finish. Do you wish the installer to initialize Anaconda 3 in your Bash account? Yes. And for now, I don't need VS Code as my editor, so I would choose no. Okay, the installation is complete. Then I would open another terminal. Then I would type Anaconda-navigator and I press enter. This is the way we open the application called Anaconda Navigator. And in this navigator, we are able to control many components that are already installed inside this Anaconda distribution. When we learn Python, we mainly rely on Spyder. That is the built-in interactive development environment, IDE. We launch it. Then we are already able to enter the IDE. On the left-hand side, you see it is a place for us to type the code, and it is also a place for us to save the code into a PY file. And on the right-hand side, you can see a console that can return the output from the PY file. And for me, in order to facilitate my teaching, I would like to do some changes in the preferences. I would increase the font for both the plain text and rich text to 18, so that the fonts are a bit larger. And also, I would change the syntax coloring to Monokai. And let me increase the space for the left-hand side. And you see there is a thin line here, almost in the middle of the screen. This is a line that represents column 80 of the py file, it is suggested that we don't write the code that is too long, that it exceeds this line. Otherwise, your readability will be affected. In order to give me more space for the console, I would like to change the window fill to another one. Click Fill, Window Layouts. I would choose Horizontal Split. Yes, in this case, I will have a larger area for my console. And I would also move the separating line a little bit to make the thin line appear again. And that is the end of my setting up of Anaconda that we will use to learn Python. After we have set up the environment, I'm going to use both the console and the py file editor to help us use Python. Let me show you the way to use the console first. Suppose I want to print something. Welcome to my course. Yes, when I press enter, this sentence will come out. This is the general idea of using the print command. I can also use single quotation marks. I will get the same result. And now let me show you some ways of assigning a value to a variable name. Suppose you want to save the savings account to $1,000. In this case, when I press enter, 1,000 is saved into the savings variable, and it is called an integer assignment to this variable name because 1,000 is an integer. We can print savings, print here, or if we are on the console, we can simply type savings. We will still get 1,000. And another data type is float. For example, hours of sleep equals 7.6 hours. What does it mean by that? We assign a float value to this variable, hours of sleep. In addition to integers and float numbers, we can also assign some strings or a collection of characters into a variable. For example, my feeling is set to be happy. So the word happy is stored in feelings, and this variable feeling does not store these two quotation marks. It simply stores the things inside the quotation marks. Okay, and we can also have Boolean variable like this. Is sunny equals true. It is known as a Boolean statement. Or we can also have another value called is cloudy equals false. When we use a Boolean variable, we have to notice that the true begins with capital T and the false begins with capital F. We can also have another value called a range value. Adult range equals RNCE 1865. What does it mean by that? It refers to a range object that contains the values from 18 to the value just before 65. So it contains 18, 19, 20 up to 64, but it doesn't include 65. Let us print it out. You see, this is the result coming from the adult range variable. We can also figure out the type of a certain variable by using the type keyword. For example, type savings would return int. Type hours of sleep would become a float. Type feeling would be a string because it stores happy. Is sunny would have a type of Boolean. And for the type of adult range, it would be a range. So it is a range object. Let us try to use the script editor on the left-hand side. We can create a new file, and in order to save some space, I'd like to remove these statements, but we don't remove these two because your Python interpreter requires these two statements to execute your code efficiently. I can do something like this: savings equals savings plus 1. What does it mean by that? I'm going to assign this value to the left-hand side. Because I haven't mentioned savings here, I'm going to say something here. Savings is equal to 400, and line 5 will change savings from 400 to 401. This is perfectly acceptable in computer science, though it is not acceptable in mathematics. Okay. I'm going to assign 401 plus 1 to savings. This is my intention. I will savings. When I print savings, I will get 401. How can I run that code? I press run file, and you are required to save the name. I simply use untitled2. And after that, I would see the result here on the IPython console. In addition to doing this assignment, I can also do the same thing by using a certain shorthand form. Let me cut it and paste it here. This statement is also equal to the previous statement here. It is simply a short form, and the plus equal sign, it means that I'm going to add the original value by 1, and I would save the new value to the original variable. Let us see the result. You see, 401 appears again. We can do the same kind of assignment for subtraction, multiplication, and division. So all these kinds are valid. Okay, and their short forms are like this. Okay, these lines would do the convention of a variable to another, and the result would be saved into the original variable name. Okay, so let me run it. I don't get the values because I haven't printed them out. So I would like to do the printing by this command, print savings. As you see, the final result is 399.0 after doing all these operations one line by one line. If we are given a data type, can we change it to another one? Sometimes we can do that. Let us see an example. The hours of sleep need is 7.6. Of sleep becomes int. This statement is going to convert 7.6 to an integer, and then I will store that integer to the original variable name. So let us see what I will get. Let me comment out these things first. print it out. Sorry, EP. As you see, 7, which is an integer. Okay, and I can get the type of this variable. It is no longer a float value, but it is now an integer value. Suppose we have a number, for example, 600 as my savings account value. I can change the integer to a string by doing the string typecasting. Let's say VINGS. I can print out savings and the type of it. What will I get? Let us see the result. You see, I have printed out savings, but the type of it is now string. Although the string is containing only numbers, it is still regarded as a string. So, doing this type of typecasting, you are able to change a type to another. The previous one is also an example of typecasting. So I hope that you're able to understand the basics of using the IDE as well as the basic assignment of variables and the printing out on the console. Hello, let us start the way we comment in Python code. Why do we need to do comments? Because we need to add some more information about the code. For example, let me do it here. For example, when I have a member list like this, when I have such a list, I might need to add some information about this list. For example, I can say that the list is provided by header. This is something that is not directly related to the content of the member list. It is some kind of additional information about the list. In this situation, I can add the comment by using a hash sign at the beginning of a certain English line, and this is known as a line comment. But we don't do comments on some trivial information about the code. For example, if I want to print out a list, I won't say that I would print a list in terms of comment. This is a bit useless to the reader of the code because the command here is already sufficient to convey this idea. In this case, we don't need a comment. And other than the line commenting, we can also have multi-line comments. For example, like this. We use three single quotation marks as the beginning. Then I would say that the date of editing of this code is that day, and the code is John. Then I end the multi-line comments with another 3 single quotation marks at the end. In addition to using single quotation marks, we can also use 3 double quotation marks at the beginning and 3 double quotation marks at the end, like this. This is also a block comment. It can contain 2 or more lines. Okay, when I run this py file, you can only see that the member list is printed out. All other things like the line comment and the multi-line comments are not entertained by the Python interpreter. So remember, we use comments to provide additional information of your code, but we don't simply restate the meaning of the code by means of comments. Hello everyone, let us discuss the integer type. Integer type is a pretty basic data type for Python, and an integer is simply a number without decimal places. So let us see some examples. We can set a equal to 1 or b equal to 2. So a would be 1 and b would be 2. How about c equals 1 plus 3? Let us print out c. We will get 3. And this is the basic operation of integer types. We can do addition, subtraction, multiplication, and division. Let us see some more examples. Suppose we need to change the value of b to this quantity, b times 4. We have to notice that in mathematics, this kind of operation is not allowed because we don't have both the values on the same side to do mathematical operation. But in computer science, this is a bit different. When we see the equal sign here, it tells us to assign the value on the right-hand side to the variable on the left-hand side. So we would put b times 4 to b. Initially, b is 2, so the right-hand side is equal to 8. So the final result is to assign 8 to b. So let us see the result. Print b, you see, b is equal to 8 now. It is no longer equal to the original value of 2. Again, we can do something like this, c equals c minus 4. So we would have c equals to minus 1 as the answer. Yes, because c was initially 3, but 3 minus 4 is minus 1. So c is now minus 1. And let us tell you more operations on integers. We can do it this way. b star 4. And this symbol means that we do the power of b by 4 times. So it is equal to b times b times b times b. We have to multiply b by 4 times. So b is 8. So now b will store the value of 8 to the power of 4. It is a pretty large value. How about division? Yes, Python can do division of integers. So we can do it this way. Suppose d is equal to 6. E is equal to 2. We save f to be the value after doing d/e. The slash sign means divide. So what would we get for f? We will get 3.0. So it is the result of 6 divided by 2. Okay. We can also print out the type of f to see what's happening here, because you see there is a decimal place and the decimal point followed by 3. So let us see the type. Is there any changes? Yes. Initially, we do the division with 2 integers, but now the result would be saved as a float value. So this is the property you have to remember for Python 3. Okay. Actually, can we do some other types of division with Python? Yes. We can do a division called integer division. It means that we don't handle the division with seeing all the decimal places. we just return the quotient of a division. For example, now E is changed to 4 instead of the initial value of 2 here. Let us see the result. B double slash E. It will return 1 instead of 1.5 because we're doing integer division. 6 double slash 4. Initially, it is equal to 1.5 if we count the decimal places, but for integer division, we simply return the quotient part. We don't handle the remainder part. And actually, can we handle the remainder part as well? Yes, we can return the remainder by using another form of division. The percentage sign E, we will get 2. What does it mean by this percentage sign? It means that we want to find out the remainder when B is divided by E. D is 6 and E is 4, so we will have the quotient to be 1 and the remainder to be 2. So this operation will give you the remainder. Okay. Can we combine all these operations together? Yes, we can. Suppose we have this kind of thing. G equals B plus C brackets times D. What does it mean by that? When we see the parentheses, we have to handle the things inside the parentheses first. So we have to handle B plus C first. And after that, we can do the multiplication of this result, B plus C, to and then we multiply the B plus D by D. So let us see the result. What is the factor of G? This is that large. And why? Because B is that value and C is that value. We have to do the addition of these two values first, and then we multiply the result by D, and let us see the B. B is 6, so you can expect this large number when we do this operation. Of course, if we don't put the parentheses, the result would be a bit different. B plus C plus D. In this case, we would do the multiplication and division first, followed by addition and subtraction, which is the logic used in mathematics. Multiplication and division followed by addition and subtraction. So we would handle this part first, and we would add the product of these two values to B, and we will store the whole value to H. So let us see the value of H. It is this value, because we have handled C times D first, and then we add this part to B. So we would get this value. So this is the end of the discussion of the integer types. Hello everybody. Let us discuss the float type. When we have a decimal point followed by some decimal places, that value is already regarded as a float value. So suppose we have A equal to 2.0. And the type of A is already a float type, even though the value of A is equal to integer 2. Suppose we assign one more variable, B equals 3.8, and of course the type of B is float. And for float types, we can do ordinary operations like we do for integers. So this kind of operation is allowed for float type. A plus B, A times B equals 5, and we would get C to be equal to 12.6. And of course, when we want to print out the type of C, we can use type C, which will give us a float value. How about operating on two float numbers that are actually equal to integers? we can see the situation now. Suppose d is equal to 5.0, and if we assign e to be equal to a times d, we would get 10.0 instead of 10. So we have to notice that e is of float type, even though the value of e is exactly equal to integer 10. We can also think of some ways to change a float number into an integer by using the int command. So we can let f to be equal to int b. So this int helps us to change the value of b, which is 3.8, to 3. Let us see the result. F is equal to 3, and the data type of f is now an integer. So you can see that int is trying to get rid of the decimal places together with the decimal point, and what we will get is simply the integer part of the original float value. Okay, so that's the end of the discussion of the float type. Hi, another variable type of Python is a string. A string is simply a collection of characters. So let us see how we define a string. Suppose I have a string like this, greeting 1, hello, and I use double quotation marks to enclose the string that I'm going to print out. Print out like this. Yes, I can see hello being printed out on the console. I can also use a single quotation mark to enclose the string that I'm going to print out. Greeting 2. Yes, I can still print out hello. So you can use either the single quotation marks or the double quotation marks. If my string really needs the quotation marks to be printed, how can we handle these quotation marks? We can see some more examples about this issue. Greeting 3 equals, it's a beautiful day. You see, if I want to print out the single quotation mark, I can use double quotation marks to enclose the string. Let me print out. It's a beautiful day is printed out, and the single quotation mark can be printed out. If I want to print out the double quotation mark, I can do something like this. Greeting 4 equals beautiful day. Print greeting 4. You see, I can print out the double quotation marks when I use the single quotation marks as the opening and closing symbols for my string. Okay. Can I stick to one quotation mark, either single or double? Yes, we can. Let us see an example. Yes, for this situation, I'm able to print out the apostrophe. So when you want to use single quotation marks as enclosing the string, and you still want to print out the single quotation mark, you have to add a backslash before the single quotation mark. If we are given a string, can we extract part of the contents? Yes, we can. We can use string slicing. Print greeting 3 to 11. What will we get? Let us see. Before that, I have to let it able to run. You see, I would like to extract the content of greeting 3 starting from the third element, and I would stop before I meet the 11th element. So 0, 1, 2, 3. So I would start from the fourth element, which is having an index of 3. 4, 5, 6, 7, 8, 9, 10. But I won't reach 11, so the string that I obtain is this part. Okay? But we have to notice something about the property of a string. We cannot change its contents after it has been established. So let us see what I will get when I want to change the second element of a string to M. As you see, it does not support item assignment. So I can't do assignment after it is given a certain value already. Okay. And let us see some more about a string. I have a user called Bonnie. I can print something like this. Greeting 1 plus user. So let me activate greeting 1. Greeting 1 is here, and I would want to combine hello and Bonnie together. So I can use a plus sign to do string concatenation. That means I simply join two strings together by using a plus sign. If we want to make it more beautiful, we can do something like this. We add a space between hello and Bonnie. So let us see the result. Yes, you see, hello, Bonnie, and the space is separating both words. There is something quite tricky about strings. Let us see the issue. Numbox equals 3. So 3 is an integer. So this variable is of integer type. We can print out to see the type. Class int. So this variable is an integer. When we want to print out this integer, we have to make it a string before we can do so. I bought str books today. I bought 3 books today. If I don't change the variable type from integer to string, I can't print out. I would get an error. Let us see the error. As you see, can only concatenate string. So when Python sees this plus symbol, it is going to concatenate strings, but not concatenate a string with an integer. In addition to printing out a single line, we can break the lines to two, or we can add some tabs. So let us see what we can do with this kind of arrangement. I'm going to have a long row. In my backslash n. Let me list them out. \n, box, \t, laptop, \t, pens. What will I get? Let us see. You see, I can break one line into 3 lines, and you can understand that \n is called the new line character. So when Python sees this one, it break this different string to another line. Yes, this \n is going to break the line to another line. So I would have 3 lines finally. And \t refers to the tab button on your keyboard. So books, tab, laptop, tab, pens. So I can use \n and \t to format my string wisely. Let us see an example about accepting a user input, which is in the form of a string. int, enter your age. This input command is going to give you a prompt, and the prompt will ask the user to input a value, and the value will be initially stored in the form of a string if we ignore the integer casting part. So age would be in the string format if we get this one. So let us see some example of it. Print type age. For example, I enter my age as 5. Enter. 5 will be saved in the age name, but the type that is going to save is a string, but not an integer, even though I put integer in my user prompt. So if I want to change it to a integer, I have to do integer casting first. So let us see what I can do. int, that one. When I run it again, my age is 6. Yes, the value would be changed to an integer type. So let me continue. If the value is changed to an integer, I can do manipulation of an integer. Next year age equals age plus 1. Print next year age is 7. So you see, my next year age variable will become 8, because 7 plus 1 will become 8. And age is an integer, so integer plus an integer will return another integer. We can also take care of the number of decimal places when we print out a string. Suppose I have a floating point number, female to male ratio of a certain club or society, 1.15653782. This is a decimal number, and I can calculate the female to male ratio by inverting it. If I want to print out the male to female ratio and the female to male ratio in a string, I can do something like this in order to constrain the number of decimal places. Print the male to female ratio is 0:.3f, and its inverse is 1:0.3f. Dot FRIMAT male to female ratio, female to male ratio. What does it mean by that? I'm going to change the number of decimal places by using these arrangements. 0 here means the first element in the format command, which is referring to the male to female ratio, and 1 refers to the second element in the inside the format method. See, 0 refers to a male to female ratio, and 1 refers to female to male ratio. And 0.3 means that I need 3 decimal places to be shown in my string. 3 decimal places to be shown on the second number to be printed out as well. And f here refers to floating point number. That means this number will be a floating point number. So let us see the result. As you see, 1.157 will be given out because I just need 3 decimal places of this floating point number, and its inverse is also given by 3 decimal places. Also, we can change excuse me, we can change the string into a number, and we can change a number into a string by means of the ASCII table. Let us see what it means. ORD means the ordinal number or the ASCII code of capital A. Let us see what I will get. You see, I will get 65. Why it is 65? Because it is obtained from the ASCII table. Let us see the ASCII table. ASCII table. Capital A is having the number of 65. So I can get 65 from capital A. And we can do the reverse process by inputting an integer and giving out a character. We use CHR 84. That means the ASCII value of 84 would correspond to a letter of what? Let us see. It refers to capital T. And we can check the table again. Yes, 84 is simply equal to character capital T. So we can always refer to the ASCII table to convert between a character and a decimal integer. So we have to remember ORD and CHR. Hi everybody, I'm going to discuss the Boolean type of Python. And when will we use this kind of variable? We use it when we want to store either true or false value in a variable. So let us do it like this. Suppose we assign a to be equal to 7. We can test whether a is larger than 9. We will get false. So a is not larger than 9. False is the result of this Boolean operation. Another one is like that. a is larger than or equal to 17. The result is false because a is 7, so it is not larger than or equal to 17. And how about this one? A is smaller than 10. Yes, it is true because a is only 7. And how about this one? We would get true for this comparison. Here, a is smaller than or equal to 7, and now a is 7, so this statement is true. And how about this one? It would get true here. This symbol refers to not equal to, so we are comparing a against 6 to see whether they are equal or not. And now 7 is of course not equal to 6, so this Boolean statement is true. And finally, we have one more method of comparing two integers. This one, a is equal to 7. Now we have to bear in mind that there are two equal signs, which means an operation that compares the value on the left-hand side and that on the right-hand side. And it is not doing an assignment. We have to notice that. We just compare a and 7. And since they are equal to each other, the result is true. We have understood the method of generating true or false results. But how can we really store this result in the variable? Let us see an example. Suppose b is equal to 9, and I let c equals b larger than 9. Here in this statement, I'm going to store the Boolean result coming from this Boolean statement to variable c. So let us print the result of c. Yes, it is false. And when we check the data type of c, yes, BOL, Boolean type of variable. So it is a method for us to store the Boolean type of variable. And of course, we can have one more operation to compare the true value of a Boolean variable, like this. Since c is already false, and we do the negation by putting a not keyword at the beginning of the variable c, it would return true as the new result of this Boolean statement. So we can do it this way. D equals not c, so we can print out d as true directly, and d is the variable that stores either true or false. And we have to notice that the true begins with capital T and false begins with a capital F. And this is the syntax of Python. When we use small t or small f instead, Python is unable to recognize that you are doing a Boolean data type assignment. Okay. We have one more way to do the Boolean operation. Suppose we have a string like this, A, B, C, D, E, to be assigned to the variable called string. We can check whether A is inside this string or not. For example, I put it as a F. So F should be true because A is actually inside the string here. So we would expect that F returns true. Let us print it out. And of course, we can check the type of F. It is a Boolean type of variable. And we can assign G to be R in string. and we would expect that G would be false. Yes, it is correct, because letter R is not inside the string that only contains A, B, C, D, E. So that's the end of discussion of the Boolean type of Python. Hi, let us discuss the use of range command. Why do we need a range command? Usually when we need to iterate over something, for example, we want to iterate over a certain list, we need some values to help us do the iteration. So let us start with the command like this. A is assigned as the range 10. What does it mean by this assignment statement? When we do list A, we can see that the variable A stores 9 values, 0 to 9. So range 10 means that we start with 0, which is the convention of Python, and then we jump the values one by one until we reach the value that is not exactly equal to the value 10 here. So the largest value that is smaller than number 10 is number 9. So the list would end at number 9. We can do the printing of the particular values inside this list of A. Yes, you see, A of A2 means 2. A2 refers to the third element of the range object. So it will return number 2 as the value here. This 2 refers to that 2. Okay. Can we simply assign the opening and closing of the range object? Yes. Instead of using range 10, actually we can also use range 0, 10 to find the start and the end of the range object, like this. When we use list B to print out the range object, I will get the same result as variable A. We start with 0 and we end with 9, which is a value just smaller than the ending value shown on the range variable here. Can we also do some other ranges? Yes. For example, this one is able to help us do the jumping during our iteration. This one. This command with 3 input arguments can help us do the jumping. It starts with -2, and we will end with number 6, and the increment is 2 for each time. So the first increment would be jumping from -2 to 0, and the second increment would be from 0 to 2, and the final one is from 2 to 4. And we can't jump from 4 to 6 because 6 is the number that we cannot reach. And how about doing the jumping backwards? Yes, we can do that. We can use this approach. We start with number 10, and we have to end before reaching -5, and the increment is -1. So in this case, the next increment would be -1, that is giving me 9, which is equal to 10 minus 1. And the second increment would give me an 8, 7, 6, and so on. And the final value for this range object is -4, because we cannot jump any further to up to -5. That is a restriction in the range command. And we can also do it another way. How about this one? When we do this variable we get nothing. It is because the jump from 8 to -4 has to result from a negative increment. But now the increment is a positive number. That means the next value from 8 should be 10 instead of a negative value. In order to achieve a negative value at the end, we have to jump by a negative increment. So this range variable gives us nothing because no values can satisfy this kind of jumping. And we will use range command to help us do the iteration, especially in the for loop later. Hi, let us discuss an important data structure called list. A list is a collection of many things, and it is quite useful for Python applications because many applications would involve lists. So let us see an example of a list. Country list equals something like this. Poland, Argentina, New Zealand, Morocco, Canada. So that is a list that stores 5 countries, and each country will be enclosed by quotation marks. It can be a single quotation mark or double quotation mark. It doesn't matter. And each element in the string, in the list, is separated by a comma. Okay, let's print out the type of this country list. Yes. We don't print out the type first, but we print out the contents contained in the country list. So we can see the contents are shown in the form of a list that starts from a square bracket and ends with a square bracket. Okay? We can print out the list type. Yes, the type is a list type. We can specify the index value of each element, but remember, Python starts counting from 0. So Poland is element index 0, Argentina is index 1, index 2 for New Zealand, index 3 for Morocco, and index 4 for Canada. Let us try to print out some of the elements. Country list 0, it will give me the first element. If I want to print out number 3, I would get Morocco. Let us see the result. Poland and Morocco. Poland corresponds to position 0, and Morocco corresponds to position 3. And in addition to specifying each element individually, we can specify a range of variables in the list. So we can do something like this. Country list 1, 3. It means that it starts from element index 1 and we will end before index 3. So I would have only index 1 and index 2 to be printed. But index 3 will not be handled. As you see, Argentina and New Zealand. And the answer will be in the form of a list. Can we do some easier slicing? Yes, we can. We can do something like this. 1 colon, and we don't specify the end. It means that we start from element index 1 and we will print the rest of the list contents. So let us see the result. We start from Argentina and we print everything until the end. We can do the other way around by printing out from the beginning to a certain element. Colon 4, it means that I will start from the beginning and I will end before I reach the element with index 4. So I will simply print out the first 4 elements. Let us see the result. Yes, I don't print out Canada because Canada is having index 4 and this index is not handled. In addition to counting elements from the beginning of the list, we can count the elements from the end. The last one element will be having an index of -1, and the second last element will have an index of -2, so on and so forth. So the final element, when we count backwards, will be having an index of -5. So let us see this property. -1. And we get Canada. And if we do something like this, -4 colon -1, what will we get? Let us see the result. Country here. Yes. Argentina, New Zealand, and Morocco. -4 is that one, and -1 is this one. So I will start with -4, which is this second element in the list. -4, -3, -2, but I don't touch -1, so I will get these 3 elements. Okay, and I can also do something like this. Print country list colon -2. What will I get? Let us see. We will start from the beginning and we will end before reaching -2 index. So I will print out the first 3 elements. As we already know that the class of this whole thing is a list class, but how about the class of the elements? We can do something like this. List 0. You see, the content of a country list with index 0 is simply a string, so we can always check the type contained in the list. In addition to setting up a certain list, we can combine 2 lists together to form a list of lists. Let us see what we can do. Person1 info equals Peter. M means male, 23 years old. Poland. He's coming from Poland. Person2 info equals Sarah. Female, 27 years old, and she comes from Argentina. You can simply print out the type of the first list, and I mean the element with index 2 of the first list. It is an integer, so element 2 refers to this one, which is storing the age of a person. And we can combine 2 lists into one, something like this. Person1 info, comma, person2 info. And let us see the result. You see, two lists are combined into one. So I have a list of lists. The big list is containing two lists, which is person 1 info and person 2 info. And I can return the type of this person list. It is still a list, but it is a big one. If we want to specify the particular element in this list of lists, we can do something like this. Oh, sorry, I have some mistake here. If I want to specify the first list in the person list, I can return the person 1 info, because it as the 0 here refers to the element with index 0 of the person list. If I want to specify the place Poland, we have to do something like this: 0 and 3. I will get Poland because 3 refers to the element index of this person list 0. So I can find out the contents level by level. In addition to handling string lists like this, we can have some more operations on a given list. Let us see some examples of handling lists. Suppose I have a student list: Kelly, Patrick, Emily, Winnie. I have 4 students in my list. If I want to add somebody into this student list, I can do something like this: Pen, Robert. I will add Robert at the end of the original student list. I can print it out. Student list. Yes. Robert will be placed at the end of the original student list by using the append method of the student list. Can we insert the names in any order that I wish? Yes, we can do so. Student list dot insert to Andy. I'm going to place Andy as element index 2 of the student list. Let us see the result. Before doing so, I'm also able to insert one more element. 0, Cindy. And let us see the result of combining these two instructions. Cindy, Kelly, Patrick, Emily, Winnie, and Robert. Initially, I have this list. When I insert Andy, I'm going to insert Andy to the third element of my original list. So after running this command, I will have Kelly, Patrick, Andy, Emily, Winnie, and Robert. And then after this list is set up, I'm going to insert Cindy to the element index 0 of this list. So Cindy will become the first element in the list, followed by any other names contained in the original list. So that's why we will have this form of student list after 2 instructions. If we want to delete something out of a list, we can use del command. If you want to delete the index number 1, we can do something like this. You see, element number 1 was originally Kelly, but I want to delete element index 1, so Kelly will be deleted. What remains will be Cindy, Patrick, and so on. Can we find out the index of some names? Yes, we can. We can use the index method. List dot index Patrick. Let's see. Patrick is having position index 1 from the student list. So Patrick will give me index 1. So that's the way the index method can help us find out the location of a certain value in the list. If you want to remove something out of a list, we can do something like this. Student list dot remove Winnie. We specify the name to be removed. Then we can see the result. Yes, Winnie will be removed, so I will have only 5 names remaining in my student list. We can also do the sorting of the list pretty easily by means of using the built-in function for us to have to do it. Student list equals sorted student list. So I will save the sorted result to my original variable name, and let us see what I will get. As you see, initially the string, the list is like this, but after sorting, I will have the names in the lexicographic order. That means I follow the dictionary order in order to print out my names. If we want to print out the elements one by one, we can have a shortcut. Print star student list, comma, SEP equals something. I put a space here. So what will I get? I will get Annie, Cindy, Emily, Patrick, and Robert, and each of the elements will be separated by space. So SEP refers to the separator. If I put a comma here, I will have the names connected by commas. We have one more thing to consider when we do assignments on a list. Suppose a list equals student list. As we know, we are going to assign student list to a list. But is it what we are going to achieve? Not always the case. And we do something more, we can see the issue. I want to change the contents of a list to Ivy, and my intention is to maintain student list unchanged. Is it really the result that I can achieve from this code? Actually not. As you see, Ivy will appear in both variable names. So that is a pretty tricky issue of lists in Python. Even though a student list and a list are intended to represent different variable contents, both will still contain Ivy. In order to resolve this issue, we have to remember one command. The list equals student list colon. When I put a colon at the end, I'm going to copy the elements from student list to the variable named a list. Initially, when I did not do something like this here, both a list and student list would point to the same list. And even though I do something on a list, the variable named student list is still accessing the same list. But when I do a colon at the end of the student list, I'm going to copy some elements into the a list. And these two variable names would correspond to different memory locations, so they don't point to the same list. Even though the contents of these two names are the same, they are not exactly pointing to the same object in Python. But let us see what we will get. I copy something from the previous code. When I do so, yes, student list will still contain CND, but a list will contain IV. And if you really want to have this intention, you have to use a coder to help you copy the contents from student list to a new memory location whose name is called a list. Hi everyone, let us discuss another way of storing data in Python. It is called a tuple. A tuple is very similar to a list, but in a tuple we cannot change its contents after it has been established. So let's see an example. Suppose we want to store some vegetables in the tuple. We will use this syntax. Cabbage, lettuce, onion, and carrot. You have to notice that we have to begin and end with round brackets instead of square brackets that we use in lists. After we have set up a tuple like this, we can print it out by showing its name. Yes, you see in the output the elements are enclosed by round brackets. Can we specify a certain index? Yes. Suppose we want to pick up the first element from the tuple. We use index 0. And similarly, we can use another index to pick up another element. For example, number -2. It would refer to the second to last element, which is onion. Yes, onion. And we can also return the index when we are given a certain element content, like this. Vegetables, tuple, index, onion. In this case, we will receive the index pertaining to the element onion, which is number 2, because tuple starts counting from 0. So 0, element 0, element 1, and element 2. Same as what we treat lists. But a tuple is different from a list in that we cannot change its contents. So this kind of operations is not allowed. We want to add up another element in the tuple, but it is not allowed. You see? A tuple is having no attribute called append. That means we cannot lengthen its contents by adding some more elements. And by the same token, we cannot change the contents. For example, if we want to change the second element to another one, B, we are not allowed to do so because tuple is a fixed structure. We cannot add up other things or change its content after it has been established. We can also find out the length of a tuple by using this command, len. It will return 4, that is the number of elements in a tuple. One thing to point out is that we can have a tuple that has only one element, but we have to do it a bit differently. If you want to set up a tuple that contains only one element, like this, we cannot do so. When we check out the type, oops, let me change it. It is a string, but it is not a tuple format. When we want to store one element in a tuple, we have to do it this way. Fruit tuple equals open bracket we have to put a comma at the end of the first element, and then we close the bracket with a round bracket. In this way, we can return a tuple. Yes, it is a tuple form, and this is the important thing you have to remember when you use a tuple. Hi, let us see another example of the data structure provided by Python. It is called a set. A set is very similar to a list, but it has some differences between a set and a list. Let us see an example. Vehicle set equals something like this. I have to use curly braces in order to set up a set. Car, motorcycle, bus, car, bicycle, bus, car. It is a set. I can have some repeated values in a set, but when I want to print out, I would simply have a set that is not having repeated values. So there is only one car, one motorcycle, one bus, and one bicycle, instead of 3 cars and 2 buses in my original settings. Okay, so this is a set. It is quite similar to the set theory that a set contains no repeated elements. In another way, we can print out the set elements like this. Print star vehicle set, comma, separator equals the comma. SEP refers to the separator that I'm going to use when I want to print out the elements in the set. Let us see the result. Yes, car, comma, motorcycle, comma, bus, comma, and bicycle, comma. We can add something or remove something from a set, like this. Vehicle set dot add ABB truck. Let me print out. When I do it, I would add truck into the set. But we have to notice that the order is not important for a set. Set is an unordered structure in Python. So we don't care about the order. As long as the word truck is in the set, it is already okay for us. So in this case, we are not allowed to do something like this. if we want to print out the third element of a vehicle set, yes, you will see the type error because set the object does not support indexing, and we don't really count the order of the elements in the set. So this is not allowed. Okay. We can also delete something out of a certain list. Out of a certain set. Discard. We use the keyword discard to do so. DUS. Initially, I added a truck, and later on, I deleted the bus. So there are only 4 elements in the latest version of the vehicle set. Something is important when we talk about sets. Let us see an example here. New vehicle set equal vehicle set. Our intention is to set up another name for the vehicle set. So the new vehicle set is assigned by the vehicle set. If I do something on the new vehicle set, by adding a van here, I would expect that the new vehicle set contains van, but the vehicle set does not. Is it the case? Let us see the result. By printing out all these 2 sets. I don't need to print out these 2 statements. You see, both the new vehicle set and the vehicle set would contain van. Why is it the case? Because of this assignment. When we say something like this, both the new vehicle set and the vehicle set would point to the same set. So when we add something to the new vehicle set, the original vehicle set will still have the same. We will still experience the same change. So here, both names would contain van. This is a property of Python. In order to avoid this to happen, we have to do some trick like this. New vehicle set equals vehicle set dot copy. Okay. In this case, I will be able to separate new vehicle set from the vehicle set. Let us see what I'm going to do. I would like to add one more element in the new vehicle set. Carriage. If I want to print each of these sets independently, I would have different results from the previous settings. Yes, let us see the last 2 results. The first one refers to the new vehicle set which contains carriage, but the vehicle set on the second result here doesn't contain carriage. This is because by setting the copy method here, I'm able to separate the new vehicle set from the vehicle set. It means that the new vehicle set is another set in the computer memory, and which is simply obtained by copying all the results from the vehicle set. So these 2 variables are disjoint. They occupy different memory locations, unlike the case here where these two names share the same memory location. Let us see another example. Suppose we have a set called set A equals 1, 2, 3, 4, and another set called set B equals 2, 1, 4, 3, 6, 7. I can use a method pertaining to a set like this. Set A dot is subset set B. Let me see the result. Yes, you see, I will return true. What does it mean by the if subset method here? In this method, I'm going to compare the set A and set B, and I would like to see whether all the elements in set A are contained in set B. So you can see in set B that I have 1, 2, 3, and 4. So set A is contained in set B completely. So set A is set to be a subset of set B. Okay, we can use a subset method to check this property. Let us see one more example. Entry list. Suppose you are now having a list instead of a set. Can we change it to a set? Yes. For example, I have a number of country names. Malaysia again. And Italy finally. It is a list instead of a set. We can print it out later to see the contents. We can also print out the type of the country list later. We can change a list to a set by using the set keyword, like this. We put a list in the argument of the set command. Then I'm able to print it out. And I can also print out this type of the country set variable. Let us see what I will get. Yes, you see, the original list is shown here, which is embraced by square brackets. It tells us that it is a list data format, and the data type is list here. And if I use the set keyword, I would change the list into a set. And during the changing process, I would also eliminate the repeated elements. So I will have only one Italy and one Malaysia. And when I print out the set, I will see the curly braces at the beginning and at the end. It means that it is a set, which is also proven by the type here. So after this discussion, I would like to say that a set is a bit tricky than a list. So when you use a set, you have to remember all these properties. Hi, let's discuss another data structure called dictionary. A dictionary is storing a lot of key value pairs, and let us see what it means by an example. Suppose I have a dictionary called student_dict, and we use curly braces to enclose the things to be put in a dictionary. Suppose I have a name called Amy:89. I would like to say that Amy has got 89 marks in a certain test. So Amy refers to the key, and 89 refers to the value corresponding to this key. And I can set up other key value pairs. So I have 4 key value pairs. the key values refer to the name, and the value refers to the mark. Let me print it out. If I want to print out the value corresponding to the key called Amy, oh sorry, I got the syntax error. I have to put a colon here. Yes, you see, 89. That means I'm able to print out the value corresponding to Amy key. And I can also change the content of the dictionary by adding one more element, or what we call the key value pair, into the dictionary. For example, I would like to add Emma, 93 marks. So after that, I can print it out. Yes, Emma is included in the dictionary variable. In addition to adding a new key value pair, I can change the contents in the original dictionary. For example, I want to change the mark for common. I can do something like this. The mark for common should be 92, so I should be able to replace 91 with 92. And let us see the result. As you see, 92 is replacing 91. For a given dictionary, we can print out the length of it. That means we can determine the number of key value pairs in this dictionary by using the len keyword. Yes, I have 5 key value pairs, so the length of the dictionary is 5. And when we print out the type of a dictionary, it will give me a dict. Yes, it is a dict type. But we have to notice something about a dictionary. A dictionary is an unordered data structure. That means we cannot say that Amy corresponds to element 0 and Betty corresponds to element 1. In fact, Python would treat key value pairs in random order. It is just a coincidence that you can see the key value pairs in this neat order. It is not usually the case for Python to return such a neat order for me. So in order to print out the elements contained in a dictionary, we have to do something else. Rather than using a for loop to loop over the indices, I would use something like this. For student mark in student desktop items, print student plus. Students something has got some mark in a certain math test. Let us see the result. As you see, Amy has got 89 marks, Betty has got 79 marks. So that means I'm able to obtain the key and value by using the keyword items here. Or more specifically, items is a method pertaining to a dictionary. Can we simply pick up the key or the value? Yes, we can. We can use another method. we use keys method. And for the values, we use the values method. We should mark here. Yes, you see, students can be printed out individually by using keys, and the marks can be printed out by using values. So at this stage, you have to realize that indentation is necessary to do iteration over a list by using the for keyword. At this stage, you have to memorize that indentation is necessary. And the printer action will loop over and over again until the student list is exhausted. If we want to delete something out of the dictionary, we can use the del keyword. And see what we will get. You see, Dorothy has been deleted. Dorothy and the marks corresponding to Dorothy are all deleted. In fact, we can combine list and with a dictionary, so that I can have a list that is contained in the dictionary. Let us see an example. My info equals something. Name, Chris, age 25, favorite languages. Python, C++, Ruby. So the favorite languages has a value in the form of a list. I can print the contents of my info. My info, favorite here. As you see, I can print the value corresponding to this key, and the value is in the form of a list. You see the contents are embraced by square brackets. If I want to check the type, I can do something like this. As you see, it is a list. So the value is in the form of a list. And if I want to pick up the value of a key from my dictionary, I can do something like this. What does it mean by that? I'm able to pick up the list content by using the index in that list. Index 1 refers to the second element in my list, so I will print out C++ as the language that has this index. Also, we can contain a dictionary in a dictionary. Let us see an example. YAME result, which is stored in the form of a dictionary. $89 marks for English. Math, 94 marks. History, 91 marks. Geography, 82 marks. Promoted, true. So I combine different data types. The values can be strings, a dictionary, and the Boolean value. Let us see how I can recall the things from this dictionary of dictionary. Result dict equals student dict student info. Results. Let me print it out. Result dict history. I can get the history mark. You see 91. Result dict is simply remembering this dictionary, and I simply get the value corresponding to the history key. We can print out the type of this 91 mark. You see, it is an integer. So I can pick up the elements in a dictionary layer by layer, even though I have a dictionary of dictionary. Hi, we can use the if, elif, and else keywords to help us control the flow of your program. So let's see an example. Savings is equal to $15. Alert is set up to be false. We have to use capital F. If you use a small f, the word doesn't change its color. So we have to use capital F. This is a reminder for you. We can use the if keyword to do something like this. If savings is smaller than or equal to 0, colon, we do something like this. We print out an English sentence like this. Time to add value to card. Suppose it is a debit card. If your savings is not large enough, the computer will tell you to add value. Otherwise, your card may not be able to function well. And we have to notice that we have indentation here. The indentation is important. It is because Python really emphasizes the importance of indentation. After we have set up an indentation like this, it means that the contents print something here would be contained in the if result. The word result here refers to the contents that would do if this condition is satisfied. So if the savings is not negative, or if it is negative, sorry, I would print something. I can extend this if statement by using elif, which means else if, but we have to use elif instead of elif. It is the short form. Okay. If savings is less than $500. Sorry, I have to set up alert to be true here. That means in this if this condition is satisfied, I would do these two steps. And if this condition is not satisfied, I would go to the elif part. I would do something like this. Be careful. Don't spend too much. Okay. It is a warning to the user who has the savings less than $500. And the alert becomes true. If these two conditions are not satisfied, I would do something else. I use the else keyword, else colon. You should still have a decent amount stored on this card. Alert equals true. And I would do these two instructions if both conditions are here and there are not satisfied. And on line 15, I would do the printing action of the alert variable. And remember, this print statement does not have indentation. It means that it is something outside of this control structure. Okay? So let us see the result. Yes, if the savings is this amount, $15, I won't go to this part, but I will go to this part. And the alert becomes true here. So I would print out true at the end. So this is a simple illustration of the if, elif, and else statements. Let us see another example. Suppose you are taking an examination and you will get the grade later. Suppose the result is unknown yet. Your grade is E. If your grade is less than or equal to capital D, your result is set to be a passing result. Else, your result becomes fail. And let me print out the result finally. So I will finish these statements and I will do the print action after that. So let us see this illustration. If your grade is E, which is actually smaller than D, I will print pass, but actually E is larger than D. And the word larger here refers to the lexicographic order. That means we search for the words in an English dictionary, and we can search for D first and E later. So D is smaller than E in this case. So here E is of course not smaller than or equal to D. So the pass result will not be saved to the result variable. What should we do? If this part is not satisfied, we will go to the else statement to do the rest. So E is not satisfying this condition, so the result variable will store fail as the value. And let us see the result. Let me comment out these things first. Yes, you will see fail here because E is actually smaller than D in the dictionary order. So this part is not satisfied. We will do the else part. Okay. And for this kind of simple if-else statement, we can use a shorthand form like this. Let me do it here. Suppose your grade is C. I can give the result in one sentence like this. Result equals pass if grade smaller than or equal to D, else fail. In this sentence, what I'm going to do is that I would like to store either pass or fail in the result variable. If your grade is smaller than or equal to D, I would save pass. If the grade value is larger than D, I would say fail instead. So C is smaller than or equal to D here, so the result will be passed. Let us see the result. By running it. Yes, passed, because C is smaller than or equal to D according to the dictionary order. Okay, so this is the shorthand form of this simple if-else statement. Okay, let us see some more examples. If Sunny is true, let me put more lines here. If is sunny, what should I do? I want you to wear sunglasses. And whether or not whether it's sunny or not, whether or not there is a sunny weather or not, I would do something else. I would do it like this. Wear your shoes. Let us see the outcome of these lines. You see, because it is sunny, I have to wear sunglasses, and this if part ends. Regardless of the result of is sunny, I will print wear your shoes. Okay, so these two lines are in the if statement, but this line is already out of the if statement. And some general guideline here. If we declare some Boolean variables, we might use it's followed by an adjective. It is a conventional way to declare this kind of Boolean variables. One more thing that is important to discuss is the short-circuiting of Python. Let us see an example. Jackpot equal 5 million, and the number of winners for this jackpot is 4, and the record high per winner is 1 million. I can check something by using the if statement. If let us do it like this. If jackpot divided by the number of winners is larger than the record high per winner, I would like to print out notice here. Jackpot per winner has broken the record. Something like this. Let me comment out these lines first. When the number of winners is 4, let me run it. I can print this statement out because 5 million divided by 4 is 1.25 million. So this amount is larger than 1 million, so I would print this out. But how about if the number of winners is 0 for this time? Oh, you see, there is a 0 division error. That means I'm going to do a division 5 million divided by 0, which is not allowed. So in order to avoid this kind of error to happen or something like this kind of exception, you can do it this way. If num is not equal to 0, and here, and jackpot divided by number of winners is larger than a certain value. What's the purpose of having this part before the jacket divided by number of winners? It is because when this part is 0, I would make this part false. And remember, for the AND operators, the first operand and the second operand would control the final result of the AND statement. If the first operand is always 0, regardless of the second operand value, the resulting AND statement would become false. So let us see the result by running it. You see, there is no error coming out because it is false, and because it is false, I won't really do the rest of the code, and even I won't do this division. So this is known as the short circuiting of Python. And let me repeat again. Because this part is 0, regardless of the value obtained on the second operand of the AND operator, the whole thing would be false. So I won't go do the second part here. And I hope you are able to understand the use of if statements and the short circuiting issue. Hi, if you want to do something repeatedly, we can make use of the control structures provided by Python. The first one I would like to talk about is the for loop. Let us see an example. For I in range 5, colon, print something. I've finished task number plus string I. What does it mean by this for loop? In this for loop, I'm going to choose different values of I from the range object, and after I've set up the I value correctly, I'm going to print out the statement here. So for this range object, the numbers contained in it are 0, 1, 2, 3, and 4. So I will be equal to 0, 1, 2, 3, and 4. And I will do the printing for 5 times. Let us see the result. Yes, you can see that I have repeated the printing for 5 times. And in each time, I would change the number at the end before I do the printing. Okay, so this is the basic principle of doing a for loop. And I have to mention something here. This is known as an indentation. If we want to set up a for loop, we really need to do some indentation so that the character of this instruction will be a bit inside of the for loop. We don't do it like this. If you do it like this, the for loop ends, and the code analysis will tell you to expect an indented block. So I have to do it by pressing the tab key. Okay, so the indentation really counts for Python. We have to remember that. Print I. So what will be the value of I after the iteration? Let me try. I will get 4 because 4 is the final value obtained from the range object here. Okay, and of course you can use another range like this to set up a different number for I. 0, 5, 2. In this case, I will print out the number differently. Let's see how is it like. I will simply print out 0, 2, and 4 because 1 and 3 are not inside this range object. Okay? Let us see another example. We don't always need to print out the things from a range object. We can simply print out something from a list directly. Suppose we have a student list. Carol. Okay. For student in student list, print student. What does it mean by that? Here, student refers to each of the elements contained in the student list. So my task is to pick up any name, and I would print out every name one by one. So let's see the result. Let's see Andy, Bobby, and Carol. In this for loop, a student will first be Andy, and for the second time, student will become Bobby, and for the third time, student will become Carol. Okay. In addition to using a for loop in this way, we can use a for loop to help us specify the index of the elements in the list. Let us see an example like this. Stock prices. Let us see the effects of using a for loop with this list. Suppose there are a number of stocks with different prices. I can use a for loop to double the prices of each of them. Colon stock prices I equal 2 times T. Stock prices I. And what does it mean here? It means that I would pick up a value out of this range object, and I would treat any object, any element from this object as I, and I will put this I into this statement. So what does it mean? Length of stock prices is 4. There are four elements. So I can be 0, 1, 2, or 3. So stock prices 0 is equal to 2 times stock prices 0. So I'm going to assign twice of this value to the corresponding position in the stock prices. That means I'm going to double up each of the prices. So let us see the result by printing it out. You see, the amount of each stock is doubled. So I can use the for loop to pick up my appropriate index from a certain list. And I hope that you're able to master the ideas of using a for loop pretty well. Hi, in addition to using a for loop to do the control structure, we can use a while loop. Let us see how it works. Suppose I have a certain task to print out. Let us see what I can do with a certain while loop. Suppose I have this variable which is equal to 0, while this variable is smaller than 5. I do something iteratively. And you have to notice that there is a sort of indentation following the line next to the while instruction. Okay. Now I have some number of tasks to do. I can do all of them. Okay. After I've printed these lines out, I would do the increment to the variable that I defined previously. And in this case, my while loop will consist of these three instructions. And when I want to print out something else by neglecting the indentation, it means that the while loop ends. And the while loop only contains these three instructions. And the print instruction is already outside the while loop. We have noticed this kind of looping by using the indentation correctly. If I do the printing like this by pressing a tab button, I would do this line of printing within this while loop, but I don't want to do that, so I have to get rid of the indentation. Out of the loop, I want to do something like this. By printing out the number of tasks that is outside the loop. Something like this, okay? Let us see the output first, and I will explain the mechanism of this while loop. Okay, you see, the number of tasks is initially set up to as 0, while this variable is still less than 5. I do something here, here, and here. I would print out the two lines. Now I have 0 tasks because num tasks starts with 0. And after printing out these two lines, I would increment num tasks. And then after the increment, the looping will start from the beginning again. But the variable num tasks is now 1 because it is obtained by incrementing the initial value of 0 by 1. Okay, so I have 1 tasks. I can handle all of them, and we will do the iteration for num tasks equals 2, 3, and 4. Okay, but how about task 5? We can't do so because when num tasks is incremented to 5, during the looping again, well, while 5 is smaller than 5, this condition fails, so we won't do the looping when num tasks is 5, which is smaller than, which is not smaller than 5. So we will end the looping, and out of the looping, I would print out next instruction that is outside the while loop. Okay, so this part is outside the while loop by aligning this line with the same column as the while keyword. Okay, so this is the basics of a while loop. We have to notice something when we use a while loop. Suppose I forgot to type this sentence. I will have this while loop that contains only 2 printing out instructions. Okay, what will I see? You see, my iteration continues, and you see that the number is always 0 because I don't change the number during the iteration. So when num tasks is always 0, this condition is always satisfied, and the printing processes will take place all the time without any stopping. In order to stop it, I have to press Ctrl C by giving a keyboard interrupt. Then I can stop it. Okay, this is one example of a while loop, and we have another example which is quite common in accepting user input. Let me do the indentation. Yes. Suppose I have a user input equals input, enter y or n. Remember that input here is a reserved word for Python that accepts a keyboard input, and the keyboard input is stored in this variable as a string. After we have set up the keyboard input, we can check the input by using a while loop. While the user input obtained by the user is not either y or n, I have to do something. We have to end this line with a colon. We have to remember that. Of course, we have to bear in mind the indentation when we do a while loop. User input equals input, enter y or n, which is exactly the same as the code on line 11. What does it mean? Let me finish it, and then I will explain the mechanism to you. You entered user input, which is valid. Okay. When I have this while loop, it means that if the user input is not y or n, I will ask the user to input again and again and again. Only when the user input variable stores y or n, I will jump out of the while loop and I will do the rest outside the while loop. Let us see the effect by running it. Enter y or n, I would press J. You see, because I have entered J, and J is not in this list that contains y or n, the user input request will appear again. So I try another one. For example, W. W is not in y or n, so I will also need your input again. Same as G, same as N. But N is a bit different. If I put N here, while N is not in N, I will do something like this. But N is already, but my user input N is already inside this list, so I won't do this part. Instead, I will jump outside the while loop to do the rest. That is, you entered N, which is valid. So I hope you are able to understand the way we control the while loop to do iterations for us. And remember, when we do a while loop, we have to realize that whether we are having a danger of formulating an infinite loop. If we want to print out the index of a list together with the content of the list, we can use the enumerate command. Let us see the meaning of it. Suppose I have a list called computer list equals laptop, mainframe, smartphone, desktop. So this list is going to store different types of computer. If I want to print out the index and the elements together, I can use enumerate command. enumerate computer list. I can print out the type. UMRATE. Yes, you can see that enumerate command will give me an enumerate object, and the type of this is called enumerate, and that part is the memory location of this enumerate object. If we want to really do the printing of the elements and the index, we can do something like this. For item in enumerate computer list star equals 100. Say we print item print type item. What will we get? Let us see. You can see that I'm able to print out the things contained in this enumerate object, enumerate of computer list. This refers to the index which starts from 100, and the first element in the enumerate object is laptop. So 100 laptop, 101 mainframe, so on and so forth. And each item is in the form of a tuple because you can see that there are round brackets enclosing the index and the element. If we don't say the starting index number, we simply have 0 as the starting index. So we can flexibly change the starting index by using start equals something. If we want to pick up the index and the element separately, we can do something like this. Element in enumerate computer list start equals 1. Print item plus string of I. What will I get for this loop? You can see that I have printed out 4 sentences. Item number 1, represented by I, is element laptop, and the element refers to the second component of a tuple, and the index refers to the first element in the tuple. Okay, since we start with 1 for this time, and the starting index of the item will be 1 instead of 0. We can also do enumeration on a string. Let us see how it works. My string equals computer, which is a string. If we want to list out the index and the letter of each character from computer, we can do something like this. I char in enumerate my string start equals 1. Letter string I is something. You see, letter 1 is C, letter 2 is O, letter 3 is M, so on and so forth. So I would be able to return the index and the character from a given string by using the enumerate command. If we want to print out the contents in the enumerate object, we can change it to a list. Let us see how it works. Enumerate list equals list enumerate computer list. We can print it out first to see the contents of it. And then we can print out the type of this variable. You see, enumerated list is in the form of a list. You can see the contents are enclosed by square brackets, and each element in this list is a tuple. So the class of the whole enumerated list is a list, and each element is in the form of a tuple. And in the contents of the tuple, we have the index and the elements from the computer list. Hey guys, when we do iterations, we used to loop over the contents inside the loops over and over again, and there was no way to stop the looping, except that we have looped over each of the elements inside a certain list or range object. But actually, can we do some ways to stop the iteration or to do some interruption of this iteration? Yes, we can. We can make use of the keywords called break and continue to help us do that. Suppose I'm going to print out the names of the students who need to pick makeup class due to their failure in a certain test. So suppose the students are stored in this list: Gloria, Helen, Ivy, Jenny, and Kitty. And I know that only 2 students passed the test. Passed student list equals Helen, and 1 more, Jenny. So only these 2 students passed the test. So the remaining 3 of the students, Gloria, Ivy, and Kitty, would need to join a makeup class. So how can I print those 3 people out? I can do it this way. For student in student list, if student in past student list continue, print student makeup class. So the mechanism of the iteration is like that. I want to loop over each element from the student list, and if I find that the student from the student list is already inside the past student list, I do not do the rest of the code followed by the keyword continue. So for example, if student is Helen now, if Helen is in past list, I don't do the rest, and I will do the iteration for this next time, so that I will loop over Ivy, so Ivy in student list or not, and we will do the things again and again. So when we see the word continue, we don't do the rest of the code, and we will go back to the beginning of the loop to do next iteration. And that's the idea of using continue. So in this case, we can see the result. Gloria needs the makeup class because Gloria is not in the past student list. I have to do the printing because the keyword continue doesn't work for Gloria because Gloria is not in the past student list. I have to do the printing for Gloria, Ivy, and Kitty. And for Helen is in the past student list, so it would go to the continue keyword. That means I will go to the beginning of the loop to do next iteration. And that's the major idea of using a continue. Let's see another example that uses the break keyword. When we use break, we would have another logic behind that. For example, while true. Suppose we ask some input from a user. Like this. Remember that I'm going to print out the single quotation marks. So I have to use the backslash as the escape character so that I can print the quotation marks out. Oh, okay. User input is going to accept a certain letter. So if user input is equal to Q, I have to do the break part. What does it mean by that? When we see the word break, we will go outside the while loop and no longer go back to the iteration again. So let me finish the remaining part of my code first. Your input was user input. Okay. When we have this logic here, if the user input is exactly equal to Q, I would jump out of the while loop and do not do the printing. What does it mean by jumping out of the break? The while loop? It means that I will go to line 16 instead of looping over again and again and again, starting from line 11. So if I have something to do on line 16, the break command would simply let me go to do the instructions outside the while loop, and I won't go back to the while loop again. So when I see the character Q, the computer would kick me out of the while loop. So let us see the result. Let me enter a letter R. My input R. So R doesn't meet the breaking condition, so I would do the printing. E again, I would print out the value of E. But how about Q? Okay, when I see the word Q, I would break the while loop so that I will not continue the looping. And if there are other lines of code starting from line 16, I would do the code starting from line 16. So we can use break and continue to control the looping, such that we don't always loop over each of the elements in a list, or we don't do the while loop over and over again. Hi. After you have learned the control structures like for loops and while loops, you are able to combine these two control structures to do some more complex looping. Let us try an example like this now. Suppose we have two schools and there are students from these two schools. So I have set up the list of the names for the students come from these two schools. School A has Alan, Ben, and Colin. And School B has other students called Ben, Emily, and Fiona. So the students from these two schools would fight against each other in a certain race. So what are the fixtures of these competitions? We can use a for loop to do so, but this kind of for loop is a nested for loop. That means I have two levels of for loops. Let us see how it works. For student A in school A students, for student B in school B students, print student A versus student B. So let us see how it works. When I run it, I can list out all the fixtures of school A students against school B students. So let us see how it works in the two-level for loops. When I want to fix a student from school A, I would also fix one of the students from school B, and then I would print out student A versus student B. So we can see the order like this. When we fix Alan from school A, we would try Dan, Emily, and Fiona from school B respectively. So Alan versus Dan, Alan versus Emily, and Alan versus Fiona will be the first 3 rows to print out. After school B students have been tried, school A students would become Ben, BN. Okay, so for Ben in school A students, I would loop over school B students again. So I would have Ben versus Dan, Ben versus Emily, and Ben versus Fiona. And finally, student A becomes Collie because student B from school B have already been looped when school A student is Ben. So we go to Collie, which is the last element of school A students. Collie would fight against Dan, Emily, and Fiona respectively. So this is the looping. When we fix some element in the outer for loop, we loop over the elements in the inner for loop. So we will have this kind of order. We can see one more example which involves 2 levels of while loops. Let me comment them out. Suppose A is equal to 1, B is also equal to 1, while A is smaller than 3, I do a loop. While B is smaller than 4, I do another level of looping. So to print A equals some string of A plus B equals string of B. B plus equals 1 means that B is assigned by B plus 1. And here I would say A plus equals 1. So A is changed to A plus 1. And I'll put B equals 1 here. So for this 2-level looping, I would have some new results. Let me try. Yes. When I run it, I will have these outputs. What does it mean by that? When A is smaller than 3, we do something here. At first, A is equal to 1, so this condition is valid. We will do the while loop inside. So B is 1, so it is allowed. I would do the printing. A is 1, B is 1, and I increment B by 1. So B is now 2. When B is still smaller than 4, I would do the printing again. At that time, A is still 1 and B becomes 2, so I would have this output. B becomes 3. 3 is still smaller than 4, so the printing would still continue. So I have A equals 1 and B equals 3. And I add up 1 to B, B becomes 4. But here 4 is not smaller than 4, so I would jump out of the while loop because this condition is no longer valid. I would do it here. This part is finished, so I would do the rest of the outer while loop. A becomes 2, by adding 1 into the original value of a. So a becomes 2. 2 is still less than 3, so we do the looping. And before that, b is set to 1 again. So 2 is smaller than 3 and 1 is smaller than 4. So I would do the printing again. But now here a is 2, b is 1, and when we repeat the loop in the inner while loop, we will have a equals 2 and b equals 3, a equals 2 and b equals 3. When b becomes 4, that condition is not satisfied. So I will jump out of this while loop to the rest of the outer while loop. And now a becomes 3. So 3 is no longer smaller than 3. So I would even jump out of the outer while loop. So the printing stops. And I hope these two examples would let you know the mechanism of looping by combining both the for loops and while loops. Hi, let us talk about logical operators. A logical operator needs two operands that are Boolean values. That means a logical operator will compare the two sides of the Boolean values to get a certain result, and it would return whether the combined statement is true or false. So let us understand the operation of the logical operators with examples. Suppose we set up assembly to be true, and we have to understand that in order to set up a Boolean variable, for true value we have to use capital T, and for false value we have to use capital F. And then assembly today assigned by not assembly. So what does it mean? Assembly today is storing the negation of the assembly result. So that means this variable will store false instead of true. We can print out. And let us run it. Yes, it is false. It means that the assembly variable is negated by the not operator, which is a type of logical operators. Let us see another example that explains the AND operator. For example, a is equal to 1, b is equal to 2, and now let's see the Boolean statement that is combined by AND. A equals 1 and b equals 3. What does it mean by that? I would like to mean that the variable c is storing the Boolean result that is generated from this combined value. So I would like to check whether a is equal to 1 and at the same time b is equal to 3. So let us see the result by printing it out. And in order to save some space on the console, I would like to comment out my above code. To print out C, I would get false. The reason is that even though A is exactly equal to 1, B is not equal to 3. So you can see that in order to make the statement, the combined statement true, both sides of the operands before and after the AND operator have to be true. I mean that they both have to be true in order to make the whole statement true. Let us see another example. Suppose b is assigned by b larger than 0 and b smaller than 5. What would we get for b? Let us just try. Let me comment out this one. You see true as the value stored in variable b. The reason is that a is larger than 0 and b b is also smaller than 5 because b is 2 and 2 is smaller than 5. So when both sides of the AND operator are true, the whole statement will become true, and that's the value stored in variable d. Let us see one more example about the OR operator. Suppose I would like to set E to be equal A equals 0, or B equal to 2 or not. Let me ignore the printing of D. What would we get for E? Let us see it. We will get true. The reason is that even though A is not equal to 0, B is equal to 2. So when either one of the sides of the OR statement is true, the resulting value will be true. So E will stay as true. This part is false, but this part is true. False or true will still give us a true value. Okay. Let us try one more example about the OR statement. I would like to save f as the result of this logical statement. A is larger than 4 or B larger than 3. So A is equal to 1. It means that this part is not valid. B is equal to 2, so this part is also invalid. When both sides of the OR statement are invalid, false or false, we would get false as the answer. So let us see the result by printing it out. Yes, it's false because both sides of the OR statements are false. In addition to using AND or NOT independently, we can combine AND or NOT operators together to form some complex logic operation. But we have to remember something that is important. It is about the precedence of the operators. In general, we have to handle NOT and followed by OR. So it means that NOT has the highest priority, and the AND operator would be below NOT, and the OR operator is below AND. So let us see some examples about this kind of operator precedence. Suppose age is 20 years old. Savings equals 30,000. If I want to sell some investment plans to this guy, I would like to check whether this guy is eligible or not. So I would use this eligible equals age larger than 20 and savings larger than 40,000. So what would you guess about the value stored in this eligible? I would treat it as follows. If it's eligible, I would like to print something. Sell an investment plan to this client. So do you think that I will need to sell an investment plan to this client? Let us see the result. Oh, sorry. I have to do it like this. Yes. You see that there is no printing out on the console. It means that the is eligible variable is storing false. That is the general example. This is the same as the general example shown above. We have to ensure that both sides of the AND operator are true in order to do the printing out. But how about other situations? Suppose age is 20 savings is again 30,000. Is retired equal true. For some reason that Yang Gan is already retired, and I've set up the eligibility to sell an investment plan as follows. Savings larger than 40,000, or age larger than 30, and not is retired. If it is an eligible case, I would still want to print out the selling notice to the seller. Okay. So what would we get when we have these conditions? Let us see the result. I still print out nothing. And the reason is like this. When we see and or not together, we have to remember that the computer would handle the not case first, followed by the and case, and finally followed by the or case. So in this condition, we have to test this one first. Is retired is true, so not is retired means false. So the second operand of the AND operator is false. So this part is false, okay? And the age is 20, so this part is also false. So false and false, we can see that this part is false. So we have to see whether this one is true or not. We have already understood that this part is false, so it means that the second operator of the the second operand of the operator OR is already false. So we have to check whether this one is also true or not. The savings is only $30,000, so this side is also false. False here or false here, we would return a false value to the is eligible. So it is false. So that's the way we handle the operator precedence, and or not, in this order. Let us see another example. Interest 30, savings equals 50,000. Is retired equals 4, and the eligibility condition is the same as the previous one, so I can copy and paste it. Yes, this one. If it is eligible, I would like to print out the notice to the seller. Let me comment them. Okay. For this case, we have to sell an investment plan. Let us see the reason. Again, we have to handle the and or not precedence. We see not here, so we have to handle the not part first. Not is retire here. It means that guy is not retired. So the not false means true. So this part is true. And how about that one? 30 years old is still not larger than 30. So this part is false. So we have false, and true. So that part is false. This is false. So we have to consider this part, which is the first operand of the OR operator. Savings is $50,000, so it is larger than 40,000. So we have true or false here. In this case, true or false means true, because we need either one of the operands to give us a true value in order to set this is eligible to be true. So in this case, we have to do the printing. Let us see one more example about the precedence issue. Suppose the age is 40, savings equals 20,000. is retired equals false. Now the eligibility condition is changed to this one. I have to add the parentheses here and there. What does it mean by the parentheses? In fact, the parentheses have a higher precedence than not. So the statements shown here will be handled first instead of handling that one first. When we see parentheses, we have to solve the problems inside the parentheses before we can do the rest. So in this case, the logical operation would be that one followed by this one, and the whole thing altogether connected by the AND operator. So let us do the rest by copying and pasting the eligibility notice. And let me comment out the previous code. Yes, I would still see the setting notice, and let us see the reason why. We see the parentheses, so we have to handle the things contained in the parentheses first. Savings is only 20,000, so that part is false. But age is 40, which is larger than 30, so this part is already true. False or true means the whole thing is true. And let us consider the next part is retired, is false. So not retired is true. So that part is true, and the other part of the AND operation is also true. True and true. So we would have the true value being stored in this eligible variable. So we would need to print out the setting notice to the seller. So I hope that you're able to understand the operation of NOT, AND, and OR operators, and it is important to remember their precedence. We have to notice that Python is not able to do everything. When it requires to do something special, it has to rely on some built-in modules to help it to do. So in this section, I'm going to introduce the basics of two built-in modules of Python. The first one is random. And I want to call a module, I have to do it like this: import random. And the import statement is best to be put on top of the rest of your code. When I have this random module imported, I can do it something like this: number1 equals random choice random and in to 9. What does it mean by that? I want to generate a random number between 2 and 9 inclusively. That means the possible values that can be returned by number 1 here is 2, 3, 4, 5, 6, 7, 8, and 9. Okay. When I want to print out, I can do it like this: number 1. You see, this time I would get 7, but next time I would get 4. As long as the value is between 2 and 9 inclusively, all of them are possible answers to number 1. Suppose we have a student list: Amy, Betty, Kathy, Doris, and Esther. If I want to generate one name from this student list randomly, I can use this approach: student1 equals random dot choice student list. So I would pick up one of the names from the student list, and I would save this name to student 1. Let us see the result. And let me ignore the previous parts. You see, this time I would get Esther, and the next time I will still get Esther. But how about the third time I get Amy? So this is the way to choose a list element randomly. We use random.choice. Here, the word random refers to the random module that we imported. Okay, and the choice here is a method from this random module. And of course, randint is a method provided by the random module. Okay, this is the syntax of calling a method from a given module. Okay, we can do the shuffling as well by using the random module. Shuffle, and then I can print out. Yes, and let me comment it, and also I would like to comment it. The first time I would get Doris, Betty, Kathy, Esther, and Amy. The second time I will get another order of the student list. So this is the meaning of shuffle. Okay. In addition to picking an element from a list, I can also pick up a random element from a string. Let us see what we can do for that. char1 equal random.choice A, B, C, D, E. If I want to print it out, I will do so. For the first time, I would get D, and for the second time, I would get C, which means that I would like to pick up any one of the characters from this string, and we can use random.choice to help us do that. After I've introduced a random, I would like to introduce another common module that we usually use. It's called time. Import time. The name time is the module name. And as usual, we have to declare the built-in modules at the top of your code. When we have this module, we can do some timing from this module. Suppose that the start time equals time.time. Time.time means that we obtain the current time from the computer. For example, if it is 8 o'clock, start time would become 8 o'clock. The first time refers to the module name, and the second time refers to the method called time from the module called time, and it is the format we have to understand. For I in range 50 million, we can do a pass. Here, the pass is a reserved keyword. It means that we really do nothing. We simply let the time go. So I would let the time go for 50 million times. And after the looping, I would like to check the time used for this looping. Time elapsed equals time.time again. So after I have done the iteration again and again, the time will change, and the second assignment to the time elapsed variable would give you another time. So let us see the result. If we want to get the time elapsed value, we can do the current time minus the previous start time. So we will get the time duration for 50 million passes, and we can print it out. Let us see the result. Yes, it takes about 1.58 seconds to do 50 million passes. And if we do it again, yes, the time used for another 50 million passes is 1.61 seconds. So these are the two modules provided by Python that is quite common for everybody to use. When we want to do things repeatedly, we don't really want to repeat things by ourselves. We can collect what we want to repeat in a function, and then we can call the function to help us repeat things for us. So let us see a basic example of a function. To define a function, we use def. Suppose I want to define a function called hello, colon at the end. I would like to print something out when I really need this sentence. Hello, welcome to the console. What does it mean by this definition of the function? Hello is the name of the function, and the round brackets tells us that there is nothing being put into the function when we really want to run it. And this function is going to print out this sentence when we really run it. So I can run it like this, hello, and when I run it, I would get the result of this sentence, because when I call this function is simply helping us to print out this sentence. This is a pretty simple function. If I want to do something a bit different, every time I call the function, I can put something inside the parentheses, and we can change the output as we want. So let us see another example of defining a function, which is an improved version of my previous hello function. Suppose I can do it like this. Define hello. I can put the person to and the program program colon print hello plus the person plus program. What I'm going to do is that when I put the name of the person and the program he wants to learn, I'm able to print the name and the program out. So let us see how I can call this function. Hello, for example, David, Python. When I do so, I would pass David to the person name and Python to the program name. So I would get this result. Hello David, you are going to learn Python. That means David will be the first value to be put into the hello function, and Python is the second value to be put in the hello function. I can also do it like this. Hello, Gary, Ruby. When I do so, I would change the name to Gary and the programming language to Ruby. So you see, it's a bit versatile when you just define one general form of function to print out things differently. The word Gary or David has to be the first position inside the parentheses, and Ruby or Python to be the second position in the hello function. So those values to be put into the function are called the argument of the function. So Gary or David is the argument for person, and Ruby and Python are the argument for program. Okay, and we have to rely on the position to call the hello function, and they are known as the positional argument. When I say something like this, Ruby Gary. Hello Ruby, we are going to learn Gary, and this is nonsense to a person who knows programming. So you can see that the first argument has to refer to the first parameter in your function declaration, and the second argument has to refer to the second parameter of the function declaration, and they are known as positional arguments. So in this case, can we let the function to do something automatically by not always providing the arguments? Yes, we can do so. We can make use of the default arguments of a function. Let us see this example. Suppose I want to define another hello function. Hello2 person program equals Python. So in this function, I'm going to set up a default argument. So when you don't declare say the program that you are going to learn, I would assume that you are going to learn Python. So I can do the rest first, and the rest is exactly equal to the first one. And the difference comes with calling it. Hello2 Robert. What will we get? Hello Robert, you are going to learn Python. Since I have only one argument in the hello2 calling, the first argument has to refer to the first parameter in the hello2 function. So Robert will be stored in person. Okay, but the program is not mentioned by me, so the function assumes that I'm going to learn Python, and this is known as the default argument. Okay. As another example, Robert Haskell. Now for this time, I tell the function the program I want to learn. So when I run it, the program is no longer Python. I can change it to Haskell. Yes, you see, Haskell is being passed to the hello2 function. So it is no longer Python that I'm going to learn. Of course, we have to be careful about the order of the arguments. Haskell, Robert. When I do so, I will have hello Haskell, you are going to learn Robert. So we have to remember again that the position of the arguments has to match that of the parameter in the function declaration. Okay. We have some other methods of calling this hello2 function, like this: person equals Robert. I will still get the desired result. In this situation, I'm going to give the name of the variable that I want to declare, that I'm going to say and to pass to hello2. So in this situation, person refers to Robert. So hello Robert, And how about the program? The program is still Python because I haven't changed the program string. Okay. And when we use the parameter to put in the function calling, I would say that this is a keyword argument because we have included the parameter name when we call the function. Hello2 program equals C++ person equals Stanley. When we have this function calling, we will still get this desired result. So you can see when we use keyword arguments, the positions of your arguments can change. You don't need to make sure that the first argument refers to the first parameter and the second one should refer to the second parameter. We don't need to do so when we declare the parameter name in the form of a keyword argument. But we cannot do something like this. It would fail because you haven't mentioned the person to be put into the function. And what you are going to do is simply set up a function parameter that has already a certain default value. In your calling here, you still haven't mentioned the person to learn the programming. So this part would fail, you see. The same one required positional argument person. You haven't mentioned the person to learn the programming language in your function calling. So I hope that you are able to understand the basics of defining a function and calling a function by using appropriate argument values. In addition to helping us do something repeatedly, we can use functions to help us return some values. So let us see an example. Define total 1 a b. So I want to handle some problems with parameters a and b. I would say return a plus b. So you can see that I'm going to pass two values to the function, and I would like to return the sum of the two parameters, and I would want to call it by doing so. For example, I call it C, which is the return value of the function, total 157. When I call this function, I would get C to become 12. I can print it out. See, 12 is shown here. So the definition of the function is going to help us return the sum of two values that are being put in the function argument. So the keyword return helps us to do some calculations or some processing, and after the function has handled these operations, the function can return a value back, and we need one variable name to save the result coming from the function. So in this case, I use C to save the result. And of course, when we do function body, we have to do indentation, which means that this part is inside this function. So the scope of the return a plus b statement is inside this function. We can have some more complex example. For example, I have this one, total 2, which is another way of finding out the total. I want to put 3 arguments into the function. One value is called A, the other value is called B, and the third one is called squared, which is a Boolean value. So let us see how I define it. If is squared, if this Boolean statement is true, I would return something like this. I would return a squared plus b squared as the function return value. If it is not true, I would do the other one. I would return another one. I would do something like this. Square. So I can return two values at the same time, and the two values to be returned are separated by a comma. And in a function, we can have multiple return statements as long as we only return one of them in calling this function. So if the function wants to call this line, the rest of the function will not be executed. So that is the way a function can have so many return statements. Let us see what we will get. Suppose I want to save the result of the function as d, total 2, 3. I will print out the result. I will get 30 because I will get 2 squared plus 3 squared, which is equal to 4 plus 9. So I would get 30. If I want to return two values from this function, I would do something like this. E operation equals total 2, 2, 3, 4. I can print the result out by using the print command. Yes, I would get 5 because this statement is false. This return statement will not be run, and instead we will run this return statement. So I would get 5 and false. Is it able for us to input a variable number of arguments into the function? Yes, we can. In Python, there is a way of putting variable length arguments. So let us see an example. I want to define another function called total 3 star numbers. This star refers to a variable number of positional arguments. So let's see how we can do it. I have a variable called total inside this total 3 function, and this function is known as a local variable of the total 3 function because when the function is executed completely, this total variable will die and it is no longer in the memory. So let us see what we can do with this total variable, which is a local variable. For value in numbers, we have a for loop to find out the sum of all the numbers listed in the positional arguments. We can return the total after we have looped over all the positional arguments. See? Total keyword is passed as the function value. So after the function value is passed, this total variable will die. how can we call it? We can call it in some number of ways. Total 3, 4, 6, 3, 2. So I would like to get the sum of these four numbers whose length is not known when the function is defined. When I print the value of f, I will get the sum of all values. 4 plus 6 plus 3 plus 2, which becomes 15. If I change the number of positional arguments, I can have another value like this. Total 3, 3, 6, 7. That only contain 3 positional arguments. Print f again. I'll get 16. 3 plus 6 plus 7 will get 16. So you see the number of variables being put into the function can vary when we have 1 star, which tells us the function to accept variable length positional arguments. Can we have a variable number of keyword arguments? Yes, we can. Let us see an example of doing so. Total 4, I call this function. Numbers as the positional arguments, and 2 stars and notations. When we use 2 stars, it means that we are going to pass a variable length keyword argument dictionary. What does it mean by that? We can see how we really handle the annotations component. For k, v in annotations items, we can print out k plus comma plus string v. So annotations, which stores the keyword arguments, is actually a dictionary. So I have to use items method to pick up the things contained in this dictionary. And how can we handle the positional arguments? I can do something similar to total 3. Let's declare a local variable for value in numbers, total assigned by total plus value, return total, which is exactly the same as total 3. So in this function, I'm able to handle both the variable length positional arguments and the variable length keyword arguments. For the keyword arguments, it is stored in the form of a dictionary. So I have to use items method to help us pick up the components inside this dictionary. KV's key and VV's value. So let us see how we call this function. P equals total 4, 3, 2, 7. Input equals 3. Operation equals sum, which is a string. When I want to print out G, I would get some other values. You see, I can add up all the numbers contained in the variable length positional arguments. In addition, I can print out the content stored in the keyword arguments in the form of a dictionary. This is the key, and the value. Okay. So in this case, I can handle both variable length positional arguments and variable length keyword arguments. When we want to change the value of a variable by using a function, we have to be a bit more careful because it doesn't always do what we want. Let us see an example. Suppose I have b equals 2. I want to define a function called increment that would change b from 2 to 3. That's my intention. And I want to do it by using a function. And the function is like this. For curiosity, I just print out the value inside the function. Then I call this function out by putting b into the function argument. This is my intention to change from 2 to 3 by using this function. But I can't do it correctly. Even though the function value is cannot be changed from 2 to 3, the function itself is really able to do the increment because when I print out the content inside the function, the function content can really become 3. But this changed value is not able to be passed to the value of b. So what's the reason for that? We have to understand something about Python variable issue. When we call this function increment b, b and a would simply point to the same value of 2. So we can say that a and b are two different names of the same value, 2. And when we use an assignment statement in the function, a and b would no longer point to the same value. A would point to 3, which is the sum of 2 plus and 1. And b will still point to the original 2. So a and b are no longer pointing to the same value. In this case, when the function ends here, the value of b is remaining the same value before the function is called. You can see that the value inside the function is changed, but that change cannot be passed to the function result. So the value of b is still equal to 2. How can we really do the increment correctly? One way to do so is to return the value a to be another variable like this. We want to do it like this. Suppose we define another function like this. B is still equal to 2. We define increment in another way. A equals a plus 1. That means we are assigning a new value to a, and we can print it out for curiosity. Return a. Yes, this is the key idea of the function. After the value is really incremented, I would return the value of the function, and I was going to store the return value to the original variable, which is b. Sorry. When I do so, I'm able to change b to 3 because I have saved the return value of the function to the original variable name. So I don't really need to mind whether the function is able to affect the value which was originally outside the function. By returning the function value, I'm able to change the content pretty confidently. So this is a take-home message for you. When you create a function, it is better to return a value which will help us be sure that we have changed something. Suppose I have a list called my list equals 2, 4, and 6. I would like to produce a function that would add each of the elements by 1. So this is my intention, and how can I achieve it? I was going to do something like this. Increment list, a list equals I plus 1 for I in a list. So I want to use list comprehension to create a list and save this result to a list. For curiosity, I would print it out inside the function. When I call it, I would do it something like this. Increment list, my list. I put my list as the argument of the increment list function. And let's see what I will get to the my list. You see, in the function, I was able to add 1 to each of the elements. But when I call the function, the values in my list is not able to change. And the reason is the same for the previous increment function. When I call the function here, my list and a list would point to the same value, which is 2, 4, and 6 in the form of a list. But when I do the assignment statement inside the function, a list is going to change to another value 357 in the form of a list, and the original my list is still pointing to the original list values. So a list and my list would point to different lists contents. So when I print out my list, it is not affected by the function. So this is the lesson we want to remember. When we want to change something by means of a function, it is better for us to return the content of the function and store it in the original variable. So let us see how I can improve it. The improvement is a bit easy. I simply add something. I don't end the function with a print statement. I need to return it. Return a list, and my list is going to save the function value returned by this function call. And when I do it, you see, the function is able to increment each of the elements, and the return value is also saved by the original mylist variable name. In this case, my list is going to change from 246 to 357, and this is my aim of using this function. So the lesson is that we should return a value when we use a function in order to help us change some contents that is originally outside the function scope. But it is not always straightforward. Not all functions require the return statements in order to change the content that is outside the function declaration. Let us see an example. I want to append some elements in a given list called a list, and element to be added is called element. I want to append something to the a list. Let me print out for curiosity. And this is the end of my function. When I have a list called my list equals 1, 3, 5, append element my list 9, print my list. What will I get? I will still get 1359 as the value of my list. You see, I didn't do the return statement in the append element function, but the append method of a list is able to help me do the work pretty easily. And the reason is a bit tricky here, but I'm going to say it a bit shortly. When we call this function, my list and a list would initially point to the same values, 1, 3, and 5 in the form of a list. When we call the append method, this append method is going to change the contents of the list directly. After the change by append method, both my list and a list will still point to the same list 1, 3, 5, and 9 in the form of a list. So these two names would still point to the same list. So I would like to say that this append method is not like the assignment statement that I showed you shortly. It won't break the connection of the two names from pointing to the same object to pointing to different objects. And this is why passing values to a function is tricky. And the whole issue is a bit technical. If you are interested in more details about this kind of value passing, you can refer to this web page. There is a detailed explanation of what I discussed. If your function is a small one, you don't really need to define a function very formally. Instead, you can use an anonymous function or what we call a lambda function to help you define such a simple function. So let us see an example. Suppose I want to change a value to its value added by 3. I can do something like this. H equals lambda x colon x plus 3. What does it mean by this statement? This is a reserved word that represents a certain anonymous function, and the independent variable of this anonymous function is x. What I want to do with the function is that I want to change the input value by adding it by 3. So x will hold a new value when the value of x changes. So when I put x equals 5, I would get 8 because 5 is now being put in the x location, and 5 plus 3 would become 8. So x of 5 becomes 8. As another example of using the lambda keyword, we can see it like this. X assigned by lambda x colon x plus 3. 7. What does it mean by that? I'm going to store the value on the right hand side to the variable name on the left hand side. And what does the right hand side mean? It means that I'm going to set up an anonymous function, and the anonymous function is going to add a certain value called x by 3. So when I put 7 into the lambda function, it would change to 10. So let us see the result when I want to print x out. So you see, 7 plus 3 is 10. So you don't always need to define a function by using the keyword def. You can use an anonymous function like this. But I have to remind you that to use an anonymous function, the function content has to be very, very simple in just one line of instruction. We have seen so many built-in classes and built-in methods. For example, when we define a list, we can have a list like this. This is an object from a list class, and we have a method corresponding to this list called append, say. When we append a number 5 to the list, I will get the list changed to having 5 elements. Okay, so I have a list object, and I can have a method pertaining to this list object. Can we actually create our own classes and own methods corresponding to that class? Yes, we can. And this is the topic of this section of the video. Suppose I want to create a class called engineer. I use class engineer : suppose every engineer remembers this motto: serve people professionally. So every engineer has to serve people professionally. This is a really, really simple class. If I want a person to be an engineer, I can use this syntax. So the person variable is now containing an engineer object. So that process is known as instantiation. I instantiate an engineer object called person from the engineer class. We can print out the motto. You see, when I want to print out the motto, I can print out serve people professionally. And this motto variable is known as the class variable. It means that every object that I create from this engineer class will have this variable. This is a pretty simple class, but can we specify the engineer in more detail according to your own class settings? Yes, we can. Take a look. We can elaborate the engineer class engineer motto equals the same sentence. So every engineer will have this motto in his mind. And in order to set up an engineer specifically, we can use an initializer, which is in the form of a function. Self name years equals 0. Self here refers to the object itself. I will discuss it a bit later. And name and years are the engineer name and the engineer experience in years. So when I set up a certain engineer object, I can specify the name and the years inside the round brackets. We will see the effects later. Let us finish the code first. Self name equals name. Self dot years equals years. Self refers to the object itself. So the object will have two instance variables called name and years. And the instance variable name of an engineer object would be having the value specified by this variable name. And the instance variable years of an engineer object would be specified by the values specified by this parameter, and I have a default argument here. So if I don't put the years in setting up the engineer object, I will have 0 years of experience. In addition to setting up an object by means of an initializer, we can also define our methods to a certain engineer object. Let us see how it works. Define work self. Print self dot name is working based on string of self years. Years of experience. And when we want to break a long string into 2 or more lines, we have to use a backslash, so that my line of code will not exceed this line, which represents 80 columns. Okay. Self.name refers to the instance variable for a particular engineer object, and self.years refers to the number of years as a particular engineer object has. And we will see the effects later, and I will also explain the word self later. I can also have another method of an engineer class, get salary. If self.years is smaller than 3, I will return something out. 50,000 plus bonus. The bonus is having a default argument. So if I don't specify the amount of bonus, I will assume it to be $10,000. If self.years smaller than 10, returns 70,000 plus bonus. Return 100,000 plus bonus. So if the number of years of experience is larger than or equal to 10, the salary will be having this amount. If the years of experience is less than 3, the amount will be like this. And if the years of experience is less than 10, the amount of the salary will be like this. So I have finished the definition of my own class called engineer. Let us produce some objects from this engineer class. Person1 equals engineer Amy 12. What does it mean by that? I'm going to set up an engineer object with its name Amy and its years of experience 12 years. And the word self here refers to person1 object itself. So the person1 object will contain Amy as the name instance variable and 12 as the years instance variable. Let us print it out. Person1.name print person1.years. I can also tell Amy to work by calling the method corresponding to an engineer class. So person1 is an engineer object, and for this object I can have a method called work. And again, self refers to the object itself, so self refers to person1, and this self parameter is already set up for you, so you don't need to really pass self into the round brackets as the argument. And I can also print out person1.model. No matter how many engineers I have instantiated, each engineer will remember this model because model is a class variable. I can also print out the salary of person 1. Get salary. And I set up the bonus to be $20,000 instead of using the default value of 10,000. Let us see what I will get. Oh, error. Name, not names. See, the name is Amy. The number of years is 12. When I tell Amy to work, I will print out this sentence. Self.name refers to the Amy instance variable. Self.years refers to the instance variable which is storing 12. Okay, and when I tell the person 1 to say it's her motto, she would say serve people professionally, and the amount of salary would be $100,000 plus $20,000, which will become $120,000, because the number of years of experience is even larger than 10. I would return this answer as the get salary return value. Let us see another example. I want to instantiate another engineer called Bobby. And notice that I don't really need to put the years of experience. If I don't put the years of experience, I will assume the years to be 0 because 0 is my default argument. I can print it out. Yes, I will get 0 for person 2's experience. And I can get the salary for person 2. This time I don't add any argument. In this case, I will assume that the bonus will be 10,000. You see, because the number of years is set to be 0, I would run this return statement to get 60,000 as the bonus. Bonus plus the basic salary, so the total salary would be 60,000. I can also tell person 2 to work. What will I get? I will get this sentence: Bobby is working based on 0 years of experience. So I can display the default argument. In addition to setting up the instance variables inside the class declaration, I can create them on the spot. Let us see what happens. I can set num_supervisor equals 2. It means that person 2 has 2 supervisors, but we have noticed that num_supervisors is not part of the class declaration. So initially, the instance variables do not consist of num_supervisors. It is something that I add now. What I print now? I can get 2. But we have to remember that this instance variable is only for person 2. For person 1, it does not contain this instance variable. So we simply add some instance variable to the particular object. and this is allowed, even though it is not suggested. You will simply change the class properties by adding something that are not based on the class declaration. And one more thing to consider when you create a class. Even though I call the person Amy, I can change it to Carol. Let me see the result. You see, I can change from Amy to Carol. But this kind of assignment is not suggested. We should rely on the initializer to help us define the properties of certain object. We don't change the object contents by initializing them outside the class declaration. It is not suggested. After we have set up the engineer class, can we produce another class based on this engineer class? Yes, we can derive another class from a user-defined class. Let us see what it means. I can derive another class called computer engineer, which is a type of engineer. So in this syntax, I'm going to create another class called computer engineer, and the basis of my new class is the original engineer class shown here. Okay, I have to initialize a computer engineer object, and how can I do that? I still use a new initializer. Self name language is equals 0. Our default argument for the initializer is years equals 0. It means that I will assume the years of experience is 0 for any computer engineer object. And I have names, I have years, and I have one new instance variable pertaining to the computer engineer. It is the language. That means the language this engineer uses in programming process. Since my engineer class already has years and names, I can try to make use of my original initializer to define my current computer engineer object. How can I do that? I can use a super keyword, super dot IIT and years. When I use this syntax, I'm able to calling my super class, which is engineer, and I use the super class to initialize the computer engineer object for me. And when I use super here, I will call the original engineer initializer by putting the names and years obtained from my new initializer to the old initializer. So I simply pass the name and years to the superclass initializer, and that's the idea of using the keyword super. Super means superclass, and computer engineer has a superclass called engineer. And how about the language here? Language is a new instance variable of computer engineer, so I need to declare the variable independently. Self dot language equals language. So a new instance variable called language is saving the value obtained from the initializer. In addition to the original methods provided by the engineer superclass, I can add my new method pertaining to computer engineer only. I can do something like this. I would print a statement when I call the method known as write code. And again, self refers to the object itself. So the computer engineer class will have write code method in addition to the work and get salary inherited from engineer class. So let us try to instantiate a computer engineer. Gary, C++, 4. It means that person 3 is a computer engineer called Gary. He knows C++ and he has 4 years of experience. I can print out the name of that person. I can also print out the years of experience as well as the language. Yes, you see, all the instance variables of object person 3 can be printed out. And I can also tell this person to write code. Yes, he's able to work as intended. And I can also tell person 3 to do some tasks about the engineer superclass. Let us see. Person 3 dot work. And see, Gary is working based on 4 years of experience. When I tell person 3 to use a method in the superclass, I will simply pass the self.name and self.years from my computer engineer initializer to the superclass method. I can also print out the salary for person 3. You see, it is 80,000 because Gary has 4 years of experience, and for 4 years the amount would be this 70,000 plus bonus, which is having a default value of 10,000. So I would get 80,000. And can we have another person which is a computer engineer? Yes, we can. I call it Nancy, and she knows Python. Because I don't give the years of experience, it is assumed that Nancy will have 0 years of experience according to the computer constructor initializer. I can print out the name. Years and the language. And let me comment out those for person 3. You see, the years of experience is known to be 0. I can also tell her to work. to write code. And I can get her salary. But I have a bonus value of 5,000 instead of the original value of 10,000. Let us see what I will get. You see, I can tell Nancy to write code. I can tell Nancy to work, and I can get the salary of Nancy because she has 0 years of experience. Her salary would be 50,000 plus bonus, which is 5,000. So she will have $55,000. And how about deriving some more classes from the original computer engineer? Yes, we can. We can actually set up another class based on our computer engineer class. See an example like this. Junior computer engineer. So I derive a new class called Junior Computer Engineer from the Computer Engineer class. I can use another initializer for my new class, self-made language probation, which is something new. Probation means the number of years of probation for this junior employee. I can call the computer engineer initializer to help me initialize junior computer engineer. And when I use the super keyword, I don't put the self argument. And there's one new instance variable called a probation, so I have to do the declaration here. And in addition to the methods provided by computer engineer class, junior computer engineer can have his own method, say write progress report. Because this guy is a junior employee, he or she has to write progress report to some senior employees. You have to pass the self object to the method. So let us see how we can make use of the junior computer engineer class. Suppose I have another person called person 5. His name is Michael. He knows Haskell. He has 2 years of probation and 1 year of experience. So that means he still has 1 year of probation. Let me print it out. As well as the number of years. Yes, I can print out all the information pertaining to a junior computer engineer, and I can tell him to work. tell him to write the progress report. And I can get the salary pertaining to this guy. The bonus is $1,000. Yes, I can tell the junior computer engineer to make use of both the computer engineer class as well as the engineer class to do all those tasks. That means I can use the methods of the computer engineer class and of the engineer class at the same time. And of course, the experience is it's just 1 year, so I would call this return value. So I would get $51,000 for the salary. So this kind of inheritance is known as multi-level inheritance. Engineer creates help us to derive a computer engineer class, and the computer engineer class helps us to derive another class called junior computer engineer. Suppose we want to create a smartphone. We know that a smartphone is a combination of a computer and a phone. So if we want to create a smartphone, we can think about inheriting computer class and phone class. So let us see how it works. We define the computer class first. It is an operating system for a computer, and it has a CPU. A computer can generate data, doing data generation. And let us create a phone class. A phone has a button, or so many buttons. I'm here to declare the type of the button. A phone can help us call people, so I will have a call method. Now, if I want to create a smartphone, I can't use the multi-level inheritance that I discussed previously, because a smartphone is actually not inherited from a computer, or it is not inherited from a phone using the multi-level inheritance pattern. Instead, a smartphone is having multiple inheritance from both computer and phone at the same time. It is not at a multi-level inheritance hierarchy. So for a smartphone, let us see how we can make use of the computer and phone classes to instantiate a smartphone object. A smartphone. Computer. Phone. In this case, I'm going to set up a smartphone class that is inherited from both computer and phone at the same time. I need an initializer for my smartphone object. OS, CPU, button, screen. Yes, a smartphone has a touchable screen, so I have to add new instance variable to a smartphone class. We have two ways to make use of the computer initializer and the phone initializer. So let me discuss the first one, which is a bit easier to understand. And I want to make use of the computer initializer. I simply type computer dot init, and I use the computer initializer parameters. And if I want to use the phone initializer, I'll use phone dot init self button. That means I simply use the phone initializer. Here we have one new instance variable called screen, so I have to set it up here. And the smartphone has a certain new functionality called enlarge screen. Enlarging image now. Okay, in this case, I'm able to set up a smartphone object by calling the computer and phone initializers. Let's see how it works. OS equals Android, for example. CPU equals Qualcomm. Button equals touchpad, which is it's not mechanical key. Screen equals AMOLED screen. Remember, when I want to break a line of code, I have to use a backslash. I can tell the smartphone to do some actions by calling its methods. First, I have to print out the instance variables for the smartphone object. OS, CPU, and then also the button type. You see, I can print out all the instance variables of this a smartphone object. I can also tell the smartphone to generate data. I can have it to make a call. I can even tell it smartphone to enlarge the screen, which is something particular to the smartphone class. You see, I can do all the things that is able to do by a smartphone. And this is one of the ways to inherit the computer and phone initializers. The second one involves some theory of multiple inheritance. It's called method resolution order. We can make use of this we can make use of the super keyword to help us initialize a smartphone. Let us see how it works. Instead of using a computer initializer, I can use super init OS CPU. Instead of using the phone initializer, I can use super computer self init button. What does it mean by that? The first super refers to the upper hierarchy of the smartphone class. What does it mean by that? According to method resolution order MRO, smartphone is having the lowest hierarchy, followed by computer and phone. The order is like this, from bottom to up, from left to right. A smartphone is at the lower hierarchy, so we go up from smartphone to computer, and since computer is placed on the left of the parameter list of the smartphone class, computer is known as the left class and phone is known as the right class. From left to right means that when we go up by one level, we will go through the left side followed by the phone side. So the super keyword here refers to a class that is one level higher than the smartphone. So I would get the computer initializer. And when we want to use the phone initializer, I need to go one level up from the computer class. So I have to use super computer self in order to call the initializer from the phone class. So computer here means the class that is going to be one hierarchy higher. So for computer, the higher hierarchy is phone. So we have two ways to declare a smartphone object by using the full name of the classes or by using the super keywords appropriately according to the method resolution order. So let us see the result. Yes, I can get this exactly the same output from the one using the full name as the initializer. So this is a bit technical. If you're interested in understanding this kind of hierarchy, you may need to read some books about object-oriented programming. Hi. After we have set up some classes and functions, we can save them on some py files like I did here. I have a number of files that stores some functions here and functions there, and I have two py files that store some classes like the engineers and the gadgets. If I want to use these classes and these functions, I can open another py file and directly call these classes and functions on my new py file. Let us see how it works. In order to use the functions from this py file, I have to remember the file name here. Then I can use the keyword import change list as CL. Change list is the py file name, and CL is the short form for this change list file name. If I want to call the functions saved at this another change list.py file, I can do the same thing to import it. Import another change list as ACL. Okay, ACL simply means another change list, and ACL is a short name for this long one. Since I want to use the append name functionality, I would like to create a certain list first. Suppose I have a name list as follows: Amy, Bobby, Chris. If I want to append a new name to this my list, and if I want to really change the content stored in my list, I have to use this method from the changelist.py file. Append name my list David. So my intention is to add David to my list, and let us see the result by printing out my list. You see, David can be added to the my list, because when I use cl.append name here, I would call the append name method from change list.py file. So when I call the append name method, I will do the real appending of a name to the original list. So David will be really added to the my list. Okay. And as you can see, I have two append name functions stored in two files. Okay, the one stored in change list is already called by me, and if I have another function having the same name from another py file, how can we do that? We can use acl.append name my list David here. So ACL refers to the py file and another change list. So when I have ACL dot something, I would call the method stored in the another change list .py file. So I don't really need to be afraid of the name clash of the two function names on different py files if I use ACL dot to begin my function call. Okay, let us see the result. Okay, let me review the append name method in ACL. In my ACL append name, I simply print out the list together with the name. So I would have this one as my output from the ACL.append name method. Okay. When I print out my list, the original list will still be the same, which comes from the first cl.append name method. Okay, so when we include import something as something, I can avoid the name clash arising from this two same names coming from two py files. That's the safest method to import and call functions from other py files. There are actually another method, but it is not really suggested, and let us see how it works. Instead of using the import keyword, we use another one. We have from from change list import append name. Suppose I simply want to use the append name function in the change list.py file. In this case, I simply use this command from the file, import the function name. In this case, I don't import pop name, so this functionality is not called by my current py file. If I want to use the append name method from another change list.py, in principle, I simply use the same technique from another change list, import append name. But you can see that is a bit problematic, as seen by the warning signal here. Redefinition of unused append name from line 14. It happens because we have two functions having the same name. So when we run the forthcoming code, only the append name function from another change list.py file will be called. The first one that I invoke is not functioning any longer. Okay, so let us see the result when I simply use the same list. Let me copy the contents. Append name, my list, save it, and let me print it out. My list. You see, I can really call the append name method from another change list.py. That is simply print out the list content together with the name that I add outside of the list. And when I print out my list, the original list is not altered because I didn't do the real appending by means of the append name method from another change list.py file. Okay, so there is some problem when we want to call both append name methods from two different py files. So this from something import something approach is not recommended. Instead of using a certain function name, you can use a star like this and here. So it means that I'm going to import all the functions stored in the change list.py file. So when I use a star, I'm going to invoke all these two functions. And when I use a star on another change list.py, I would be able to invoke append name method from this py file. So that is some concern we need to understand when we call some methods or functions from some py files. Let us see another situation in which I'm going to call the classes from two separate py files. So let me comment all these things out, and I do something here. If I want to call the engineer class, computer engineer class, and junior computer engineer class, I can use this syntax. Import engineer as eng. Here, engineer refers to the file name engineer.py, and eng is the short form that represents this a bit longer name. If I want to call the classes and the methods in the gadgets.py file, I can do the same thing here. Import gadget as GAD. GAD is simply a short name for gadget. It's up to you to assign a short form name to your long name. If I want to instantiate a computer engineer from the engineer.py file, I can do something like this. A computer engineer equals eng dot computer engineer Gordon scalar A. So I'm going to instantiate a computer engineer whose name is Gordon, whose language is Scala and whose experience is 8 years. So when I instantiate computer engineer object, I use eng dot the class name. Eng refers to the engineer.py file, so I simply refer to this class from the engineer.py file. Of course, I can also instantiate a general engineer Ada 5. Ada has 5 years of experience and she is an ordinary engineer. Of course, I can also instantiate a junior engineer, junior computer engineer. John hyphen 2-1. Probation year is 2 and he has already got 1 year of experience. So in this case, I am able to instantiate all 3 objects from 3 different classes stored in engineer.py file. If I want to instantiate a gadget, I can use the classes stored in gadget.py. Let us see how it works. A gadget equals GAD smartphone. iOS is the operating system. A9 is the CPU model. Touchpad is the keys provided by this smartphone. Retina display is the display device for certain smartphone. At the same time, I can also instantiate a phone. Keypad, because an ordinary phone is simply using mechanical keys. So what I did here is instantiate a smartphone and a phone. Okay. So let us see the results coming from these instantiations. I can get the salary of a computer engineer according to the methods provided by the computer engineer salary, which actually inherits from the engineer superclass. Also, I can print something else, an engineer.get salary. I can also print out the salary for the junior engineer. And for the gadget, I can do something like this. Enlarge image, which is a property that a smartphone can do. For a phone, I can make a call with it. You see, I'm able to get the salaries for different engineers, and I am able to enlarge an image, and I can make a call with my phone object. Okay, so the idea is pretty similar to what we did with calling functions from py files. Of course, you can also use the from something, import something terminology to do the import. Of course, this is not really recommended for the name caching reason. So let us see how it works, even though it is not suggested. From engineer import computer engineer. Suppose I simply want to instantiate computer engineer. Suppose I simply want to instantiate a smartphone object. Then I can do something like this. Another computer engineer is assigned by the class initializer. I have another computer engineer having the same contents as my previous one for simplicity. In this case, I'm able to instantiate the computer engineer because computer engineer is something that I really imported from an outside file. Since computer engineer inherits from the engineer superclass, it is a bit sensible for us to expect that the engineer object is also able to be instantiated. Let us see if it is the case or not. I simply want to instantiate an engineer object, which is the superclass of the computer engineer. But you see, the warning is here, undefined name engineer. Even though engineer is the superclass of the computer engineer class that I already imported, Python is not able to let you import some superclasses. Okay, let us see. When I run it, yes, you see, engineer is not found because I haven't imported engineer class explicitly. So this is not allowed. Of course, I can also try to instantiate another junior computer engineer. And let us see if it is able to do so. You see, junior computer engineer is not defined. So when I imported computer engineer only, I'm unable to instantiate the superclass objects and the subclass object. I can only generate an object coming from computer engineer class. So that is the flexibility that you will lose when you use this approach. Okay. Same for the gadget issue. Let us see the instantiation as follows. I simply add the same content of my previous smartphone object. And also, I'm able to do the enlargement by using my smartphone object that I created recently. Okay, I can do the enlargement because a smartphone class is something that I already imported. I can simply create a smartphone object from my gadget.py file. Of course, a smartphone is derived from a phone together with a computer. You can see I used multiple inheritance technique to produce a smartphone class based on the computer class and the phone class at the same time. It's able for us to generate an object from the phone class. Let us see. You see, phone is not defined. So I can simply create a smartphone object, but I can't use the smartphone class to create the object from its parent classes. So that's the restriction when I use from something, import something format. So it is not a recommended approach. In fact, most of the codes here would nowadays would use the import something as something approach. Hello. For some purposes, we need to store our output to a text file. So how can we do this? I'm going to spend a section on this file input and output issue. Let us see how we can write some text to a text file. Let me use the UI file editor here. Suppose I have something to write to a certain file called abc.txt. Okay. Here I'm going to create a file object called f, which is going to store the opened file called abc.txt, and the x argument here refers to the creation of that file. If this file is already present, you will see an exception coming from the Python interpreter. So in this case, I haven't created this file yet, so I won't see a warning or even an error coming out. If I want to write something, I'm going to use the write method pertaining to a file object. So this is the content that I'm going to write to the abc.txt file. You see I have a new line character, so I will see two separate lines when I open this abc.txt file later. I can also write one more sentence. After I have written some sentences to a text file, we have to close the file with the close method. Okay. If we don't close the file content may have a chance of corruption. So please remember, if we use open method to create a file object, remember to close it when we have finished editing. So let us see the result. Something has already been done, so I have to really open this file. Yes, you see, the lines have been added. Since I have the new line character, the lines will be broken into two. And for the second part, hope you are doing well here. The input will be stored continuously. Okay, let us see if we want to add something to the existing text file. How can we do this? We can do something like this. F equals open abc.txt. A here refers to append. That means we add something to the existing file without erasing the original content. I'm going to add some lines, but these lines are stored in list format. So here I have two strings that are stored in the list. So I have a comma separating two strings. If I want to write this list into the abc.txt file, I have to use writeLines method. Remember to close the file. And let us see the result. You see, I can add two lines that are stored in the list to the abc.txt file. And remember, when we use lists to store separate strings, the addition to the text file would be continuous. You see, no separate lines for each string object from the list. Okay. If we want to erase all the contents originally stored in the text file, we can use another method. Open abc.txt w. The w argument refers to write. It also means replacing the original contents with something new. So I'm going to erase all the lines that I stored in the original text file. Right. Remember to close the file. Let us see the result. You see, all the previous lines are replaced by this new string. Okay. As I mentioned, the closing action is really important. But when we do the real coding, it is sometimes forgivable that you forget to do the closing action. In order to avoid the manual closing all the time, Python has a simple approach to handling the closing of files, which is called with keyword. With open abc.txt, A means append, as F means the file object. Let me run it and see the results stored in the text file. You see, I'm able to add one more line by using the with keyword. And when I use the with keyword, I don't really need to close the file manually. The with keyword is able to help me close the file after the string is added. So it is a bit more convenient than using the conventional open and close approach. Let's see if we want to do the reading action. How can we do that? We still use the open keyword, but now I use R as the argument. R means read here. When I want to print the contents from my text file, I can use this approach, g.read. remember to close the file after we have read something from a text file. You see, the contents can be read by the read method. Okay. We have another way to read contents from a text file. Let us see how it works. We use read lines method. We have to remember there is an S here. And let us see the result. Yes, the results will be stored in the form of a list, with each line being one element in the list. So read lines refers to storing the things in a list. Can we do something else with the reading action? Yes, we have another keyword for us to use. We have read line method. Let us see the result. When we use the read line method, the two lines will be displayed one by one instead of storing the results in a list. Okay, so S and low S will have different outcomes. When we do the reading action, we can also use the with keyword to help us, so that we don't really need to remember to close the file all the time. For line in G, print line. Let us see how it works. As you see, line refers to each of the lines contained in the text file. So I will print the lines one by one with using the with keyword here. I can tell you one more thing about the conventional opening and closing. We can use a for loop to help us print out the contents of a text file. Yes, we use a for loop to do the displaying of each line from the text file in this way. Okay, we use a for loop to do so. Of course, we have to remember to close the file when we use the open keyword at the beginning. In addition to storing the text into text files, there is one more common way to store the contents, which is called a JSON file format, which is commonly used in many situations. So let us see how it really works. Before we do the JSON format, we have to import JSON, import JSON without a. Okay. Supposing I want to open a new file first. I can create a dictionary here. So I have a dictionary that stores the contents of a certain person. We can use this json.dump my dict h to store the dictionary to a file in the form of a JSON format. So my dict is the dictionary, h is the file object. Remember to close the file, and let us see the result. Yes, you see, the dictionary is stored in a file called df.txt, and the format of a dictionary is still maintained when I use json.dump method. Of course, if we don't want to use the close command all the time, we can use a with keyword to help us handle JSON files. Now I'm going to read contents. Let us see how it works. Yes, you see, JSON.load file means that I'm going to load the contents of df.txt, and I'm going to store the result in a variable called a. If we want to print it out, you see, the variable a stores the whole dictionary already stored in the text file. So these two involve the file management issue. That means I open a certain text file, or I write something to the text file. Let us see another example of JSON file format. Suppose I have a string called my string. This list is going to store 3 values, and I use this command. And I use json.dump as my string. I'm going to store this list in the form of a JSON format into the variable b. And let us see the result. When I print out b, the list is stored in this variable in the form of a JSON format. So this s refers to string as opposed to the dump method that is shown previously. When we want to load the contents stored in B, we can use this approach. C equals json.load s b, and then we can print it out. You see, C will be printed out as the list format stored in the JSON format. So here S refers to string. So I can print out the string in the form of a JSON file requirement. And I'm going to store it in C, and when I print it out, I will have this string coming out. when we write programs, there may be some situations that will make our program fail. If we face these situations, we have to think about some ways to handle these exceptional issues. Otherwise, our programs might not be able to run continuously to the end. Let us see some examples like this. I'm going to accept some inputs from the user, and I would like to do division. A is the dividend. B is the divisor. This is my intention to do the division. When I run it, and I input 5, and when I input 2, I'll get 2.5 because 5 divided by 2 is 2.5. But what will I do if I have something like this? 5 divided by 0. You see? 0 division error, division by 0 happens here. It means that the Python interpreter has faced some exceptional issue called zero division error, which makes Python not able to continue the remaining tasks. So when I want to print out C, the application is already halted at this stage because C equals A divided by B already stops the program from doing the rest. So if we want to address this issue by not allowing the Python interpreter to make our system stop, we have to consider the case when B is equal to 0. We can have something like this. I have a new instruction here. I use the raise keyword, and then I raise an exception. And the content of this exception is like this. You can't make divisor to be 0. So I will give you a warning if the divisor is really equal to 0. And the program will not stop like the previous situation by giving you an exception error type here. Let us see the result. 5, 0. Yes, the exception will be like this. You can't make divisor to be 0. So I simply raise some exception to stop the program from running any longer. And the exception message will be a bit different from the original one, because for this time I'm able to create my own exception. Of course, if the numbers are okay, 2.5 will still be returned by printing it out. When you see the exception here, the program will really stop by not doing the rest. So when I face this exception, the printing action cannot be done. So if we really want to do the rest of the code, we have to catch the exception, and then we have to handle the exception rather than simply making the program to stop at this stage. Let us see how it works. We have some keywords to help us do that. Suppose I still do the same thing of division. You can use the try keyword. So the computer is going to try to do this division. But of course, this division will not always work. It depends on the value of b. If we have this zero division error, we have to do something like this. We print out the error message provided by the zero division error warning. When there is a zero division error, I would print out the error as well as this statement. If there is no zero division error, I can do something like this. I simply print out the result of the division. Whether or not we have caught this zero division error, we still do something like this here. We use finally to specify the things that we are going to do, even though we have zero division error or we don't have zero division error. The second printing statement is already outside the try, except, else, finally block. So let us see how it goes. 0. You see, the computer isn't stopping your action to do the rest. So I can still do the testing complete, and let us do another test. So the finally keyword refers to the situation whether or not the exception occurs. I will still do the things specified by the finally block. Okay. Division by 0 is the error name here, and this statement is what I'm going to print when zero division error occurs. Since 6 divided by 0 is not allowed, the else part is not done, so Z is not printed out. Let us see another case. 1.5 is printed out when the division is really doable, okay, and the except part is not met, so these two lines will not be printed. In addition to using try, except, else, finally keywords, we can have another way to assert the correct data input. Let us see an example like this. Suppose I input a certain value. If I want to enter the savings amount, we have to assert that this value is not negative. We can use the assert keyword to do so. We have to assert that b to be larger than or equal to 0. If the value of d that is received by the user input is not following this condition, we can print something out. It can't be negative. If the value input stored in variable d is larger than or equal to 0, we do something else. We double the savings. and then I print it out. Suppose it is -9. You see the exception error would come out. And this is something that I tell the computer to do when the amount is negative. Okay. Let me try again. If it is 45, which is a positive number, I would get 90. I would do the rest shown here. Okay. So if the amount is negative, I would assert an exception by printing this statement out. So this kind of error is known as assertion error. In addition to asserting exceptions or meeting exceptions by chance, we can create some user-defined exceptions by inheriting the exception class. Let us see how it works. We can have a class called SumError, which comes from exception class. And we have SumError. We do some parsing. That means we don't really do something real when I call this class. I can also derive a new class from SumError. I also parse it. So how will I do the real definition of the classes? I will do it right here, when I do the try, accept, and finally block. So you see, I'm going to enter a number. If the input is not really a number, I would want to raise a not a number error. So when this error really occurs, I have to handle it by using the except keyword. I want to print a statement. This is not a number. And whether or not this not a number error is caught, I do something like this at the end. Process finished. Okay, let us see the effect. Enter a number. Suppose I'm not entering a number, I simply enter a character H. So you see, when H is received, the not a number error will be raised. And when this error is raised, I would do the printing of the sentence here. And whether or not the not a number error is raised, I would also print the final statement, process finished. So let us run again. Suppose I enter a real number called 7, process finished. The error is not raised because a number is really a number. If there is no exception being raised, I will still do the finally part, that is printing this sentence out. So I hope that you are able to understand the basics of exception issues. We can raise exceptions by ourselves, like here or there. We can use a try, except, else finally block to handle the exception so that the program will not stop all the time. And we can also use the assert keyword to produce some kind of manual exception statements. Okay, let us start the debugging process. Suppose I have a certain name list and I would like to add an element called either at the end of this name list. My intention is to write a certain function called append name, and in this function I would like to do a certain assignment statement to put one more element at the end of a list. And when I call this function, I would put my name list into the function and a certain new word to be added as the second parameter of the function. After that, I would print it out. But when I really run it, I can't see either at the end. It seems to me that this function is not able to achieve my task. So in order to investigate the problem of it, I would like to use the debugging functionality of Spyder. Before doing so, I would like to change the window layout as RStudio layout. In this case, I'm able to realize the parameters being produced during the process of the running of the code. Okay, suppose I'm pretty sure that my problem comes from line number 9. In this case, I can put my cursor next to the line number, double click, and you will see a certain circle next to the line number. It means that I've already put a certain breakpoint here. When I want to do the debugging, I would press the debug file. Okay, you see the current operation is still on line number 4, and line number 4 is not yet run. When I click on the continue execution button, you see that lines number 7 and 8 are already executed, and the next line to be executed is line number 9, which is the problematic function that I created. At this stage, I can press step into function or method of current line, and you can see that the cursor will jump to the function again. And here on the right hand side, a list is also created together with the original name list. Then I press the step into function again. This line is going to be run. And when I press it again, you can see that that line is already executed, so that either is already inside the list list. But you can see that the name list is still having only 4 elements. This means the operation here cannot be put on the name list variable. So what's the reason for that? It is because when we do the assignment statement here, the variable names a list and name list are no longer pointing to the same list here. When this assignment is done, the a list variable will be containing only 5 elements rather than 4 elements shown on the original name list here. And when we step into the function again, okay, you can see that the pointer has gone to line number 10. It means that line number 9 is already executed. And at the end of the function execution, the a list variable is lost because this variable is inside the scope of the function only. It is not in the scope of the other paths of the code. So you see the action of adding a certain name on a list cannot be transferred to the variable name list. That's why when I print it by pressing the press step into function again. Oh, when we press the step into function, you can see that I'm reaching the iostream.py, which is something internal to the Python operation. So I can press run until current function or method returns in order to leave this internal py file. Press again, yes. I can see that I can already leave the iostream.py file. And when I press it once more, I can already leave the whole debugging process. And you can see that I have already printed the name list shown here. That's the printing result that I already showed you previously. So you can see that this assignment fails. What can we do in order to achieve my task correctly? And I can first remove the breakpoint by double-clicking the circle. In order to do that, I need to change the code to a list.append and then name. This append functionality is applicable to both a list and name list here, so that I'm operating on the list content, which is equal to Ada, Bobby, Cindy, Dennis. And the appending operation is applicable to both variable names. So when I run it again, you can see that Eva is already added to the name list when I want to print it out. So I would like to say that you can use the debugging functionality shown on the two menu bars to help you understand what's happening when your code is not working as you expected. And that's the end of the debugging process. Congratulations, you have already mastered the basic skills of Python. So what can you learn next? It depends on your application. If you want to do something like data processing, you can use the corresponding packages. And if you want to do machine learning, you can use the appropriate packages for Python. And on the Anaconda documentation, you can see there is a list of packages available for Python, and some of them have already been installed for you when you install Anaconda. You can read the summary of each of the packages to know the functionality of them. Here, the word package refers to a collection of so many modules. And I would like to introduce two popular packages to you. The first one is scikit-learn, which is this one. When you click on this link, you're able to visit the web page for scikit-learn. It can do so many things about machine learning. For example, when I click on regression, logistic regression, you can see that we can call a package, and from that package we call some modules in order to help us do some operations like polynomial features or pipeline. And you can also do the fitting by using the pipeline modules provided by scikit-learn. And If you are interested in data science, you can use Pandas, P-A-N-D-A-S here. This one, Pandas. And when you look at the Pandas website, you can see the documentation. And from the documentation, you have so many computational tools provided by Pandas. The idea is to load the Pandas package, and from this package, we load the corresponding modules to help us do different kinds of data processing. And this is the end of my video about the basics of Python. Hope you are enjoyable during the course of my teaching. And if you like this video, please give me a like to the video and please subscribe to my channel as well. Thank you for watching.